carries angular momentum, frame dragging twists the orbital plane as well, a subtle nod from spacetime that the core is not just heavy but whirling. Life on the surface, if there is a surface, becomes a physics seminar. Far from the abyss, the drifter is a deep space world, starless skies, a temperature set by internal heat and any blanket it carries. Thick hydrogen atmospheres do a surprising job of trapping geothermal warmth, and tidal kneading at each close pass adds pulses of energy that propagate like planetary heartbeats. The strength of that kneading depends on the world's elasticity and dissipation, the same ingredients that light up Jupiter's moon Io, scaled to ridiculous by the mass contrast. Rocks flex, faults creep, mantles stir, and on an icy globe, high-pressure oceans may swell beneath shell ice, then freeze a little between pericenter beats, riding a sawtooth of climate into the crust. The plunge is a different universe. The sky brightens not with a sun but with a glowing, asymmetric halo, the innermost gas of the central maelstrom. X-rays and hard ultraviolet surge during flickers of accretion, charged particles roar along magnetic field lines, the black circle at the center wears a thin ring of lensed light, a distorted promise that everything luminous behind it has been bent. Radiation eats chemistry for breakfast. Atmospheres puff, upper layers haze, molecules fracture and recombine into photochemical soups that rain hydrocarbons. If the world carries a magnetic field, its motion through magnetized plasma turns it into a giant unipolar inductor, driving currents that close through the surrounding sheath and ignite auroral ovals with energies that make Jovian displays look like candlelight. Pericenter is a storm season and an electrical season and a geology season, all at once. Whether the globe survives depends on the knife edge between gravity and material strength. The tidal radius for an Earth mass body near a multi-million solar mass monster sits of order half an astronomical unit. Dip inside that and the planet unthreads into a stream. Go too far and the debris becomes a luminous ribbon, wrapped into a tight ring by differential gravity, shock-heated where the stream intersects itself, and then bled into the inner flow as dust and gas, an appetizer for the central furnace. Skirt just outside and the world lives to loop again, losing a little orbital energy each time to tides within itself and to interactions with the ambient medium. Over many circuits, the needle ellipse shortens and fattens toward a tighter path. For small bodies that process is glacial, but the direction is one way unless another kick intervenes. Detection is a game of patience and cleverness. There is no host star to dim with a transit, no reflected sunlight to flash at opposition. Instead, astronomers would look for periodic infrared brightening as the surface or atmosphere is heated at closest approach, for submillimeter or radio bursts from induction-powered aurora, for faint, transient dust arcs if volatile ice is sublimate and condense into rings that glint at certain viewing angles. The timing of those flares, together with their relativistic clock drift as the pericenter precesses, would betray the mass and spin of the central attractor. In a well-watched core, the bustling downtown of this island universe, precision astrometry could even catch the gravitational tug of a planet mass body on nearby test particles, the way the famous S-stars chart the central gravity but on tinier scales. Chemistry on a captured nomad is written by extremes. With no daily sunrise, the default climate is stratified and slow, but pericenter injects oxidants, nitriles, and radicals that never see equilibrium. On a rocky world, magma ponds erupted by tides may glass over between passages, preserving layers like tree rings that encode the timing of each dive. On an icy colossus, methane clouds could seed hydrocarbon snow that is erased on the next furnace swing, a periodic resurfacing cycle that paints latitudes by orbital phase. If a thick hydrogen envelope exists, pressure broadening and collision-induced absorption can warm the deep troposphere into habitable temperatures even in the cosmic night. Add tidal power and you have a laboratory for life that ignores suns and worships gravity. Habitability here is not a soft meadow under blue sky, it is a dark ocean under ice, keeping its own calendar by the beat of spacetime. Dynamics in the central precinct of the star archipelago never rest. Resonant relaxation rattles orbital orientations as passing stars exchange tiny torques. Correlative cycles driven by the cluster can pump eccentricity higher and inclination stranger. A brush with a compact object can tilt the ellipse into a new plane. Gas streams drifting like luminous smoke can sap or donate angular momentum depending on the geometry, sometimes herding small bodies into families of similar paths that share a preferred pericenter direction. The vagrant story is therefore not just one world and one well, it is a swarm problem, a statistical ballet of millions of pebbles, rocks, comets, and planets responding to a central verdict. Seen from far above the disk of this stellar commonwealth, a captured wanderer is almost nothing, one more dust mote obeying the deepest gradient in town. Seen up close, it is a world with seasons defined by relativity, weather written by particle physics, geology set to the rhythm of a rosette, and chemistry that remembers every encounter with the photon furnace at the core. If astronomy's usual questions begin with, "What star does it orbit?" these nomads flip the script. They orbit a geometry more than a lamp, a piece of spacetime that sculpts orbits into flowers and time into spirals. The city around them, this spiral dominion, this star-crowded burrow, this luminous archipelago, provides the crowd noise and the occasional shove, but the dance belongs to gravity and whatever stubborn sphere refused to be unmade. Say the word, and the story dives deeper, into how the precession angle maps the mass quadrupole of the central engine, how ring systems survive the torque at pericenter, how a cryovolcanic plume would look silhouetted against a lensed background, how a world can be nightbound and still warm, how capture writes its signature where even the brightest suns are only scenery. Capture has a dozen doorways and each opens with a different creak. A common route begins with a planet tethered to a star that wanders too close to the dark turbine. Tides tear the system apart, flinging the lamp outward while the smaller companion is left behind in a thin, feverish ellipse. Another path starts even farther out, where this island of stars teems with binaries that swap partners in gravitational bar fights. A three-body ricochet can rob the drifter of enough energy to fall into the core's jurisdiction. Add in the gentle drag of thin, magnetized gas that threads the downtown of the starry republic, and a small body's fate shifts from visitor to resident. The end product is the same, a path with a aphelion in the quiet suburbs and a pericenter drawn so close that the world tastes curvature. The physics of that taste is ruthless and precise. Tidal stress rises like a cliff as closest approach shrinks, scaling roughly as the inverse cube of distance, so a small change in pericenter means a large change in pain. Well outside the event horizon of a 4 million solar mass engine, a rocky globe still meets a survivable corridor. Just inside roughly half an astronomical unit the Roche calculus stops being polite, and mountains become molecules. If composition leans icy, the safe lane is wider. If iron-heavy, the world holds together longer but bleeds heat with every flex. The energy pumped into the interior during a single dive can exceed Earth's global geothermal budget many times over, and that power does not distribute evenly. Weak layers decouple, partial melts pool at depth, fault zones unlock for a few frantic days, and then the long freeze of aphelion begins anew. Relativity rights flourishes on top of Newton's grammar. Each lap, the argument of pericenter marches forward, so the track is not a closed ellipse but a rosette whose petals open by tens of degrees per orbit. If the central spinner's axis is tilted, frame dragging also nods the orbital plane, a slow corkscrew that depends on the black hole's spin and quadrupole, exactly the combination needed to test the no-hair predictions of gravitation theory. Even a planet is a clock, comparing the timing of heat pulses, induced aurora, or dust outgassing from successive pericenters against a relativistic model constrains the central mass and spin the same way the S-stars do, only with a colder, smaller, stranger probe. What bathes the surface at closest approach depends on the central furnace's mood. In a quiet nucleus, the photon bath is thin and hard, rich in X-rays and ultraviolet that carve chemistry rather than warm oceans. During flares, luminosity can spike and the energy flux at 1 astronomical unit rivals or surpasses a sunlit day. That turns atmospheres into laboratories, hydrogen envelopes puff and cool into hazes, nitrogen-oxygen mixes spawn nitrates and peroxides, methane skies polymerize into smog that snows when the world coasts back into darkness. A magnetic shell amplifies the drama. Motion through the core's magnetized plasma turns the globe into a dynamo, currents close along field lines, joule heating adds to the tidal budget, and polar ovals become brutal, flickering crowns that inject chemistry into otherwise sterile air. If the traveler carries a ring system, the pericenter ram pressure warps and may even twist it out of the equatorial plane. Resonances can drive ripples that march around like barcodes a spacecraft could read from orbit, if any spacecraft could survive the trip. How would the luminous archipelago betray one of these hidden citizens? Start where the signal is most honest: heat. Near-infrared light curves that swell and fade on the orbital timescale would be smoking guns, especially if the peaks creep earlier each year by the amount predicted from pericenter precession. Sub-millimeter flashes from induction-driven aurora would ride atop that cycle like percussion accents, and in fortuitous geometries a thin dust wake, volatile grains boiled off at pericenter and sheared into a filament, might backlight against the crowded star field. Precision astrometry in the central parsec already traces the ballet of bright test particles. A planet mass body would be subtler, but in aggregate a population would add a small, correlated noise to orbits of nearby tracers that a patient interferometer could isolate. On the gravitational wave dial, a rock looping at a few tenths of an astronomical unit around a monster is too quiet for current ears. A super-Earth pressed into a tighter, faster rosette around a more massive dynamo could creep into the lowest bands of a future spaceborne antenna, whispering an extreme mass ratio murmur at millihertz. Origin stories matter because they leave scars. A world stripped from a star within this spiral dominion might keep a residual moon, and that companion can act as a heat valve, pumping eccentricity and modulating tides the way Io and Europa share energy. A body formed in the cold outskirts of the stellar continent, then scattered inward across kiloparsecs, would arrive rich in volatiles and poor in refractory crusts, favoring ocean underice outcomes and atmospheric hazes. A fragment of a shattered super-Earth might come preheated and metallic, its magnetic shield strong and its surface bare. Some vagrants will finish as streamers after one unlucky dive, others will circularize into close-in embers that feed dust to the central flow, and a stubborn few will surf the knife-edge corridor for millions of years, carving a private calendar into rock and ice. Between passages the night is honest and slow. Without a sun, climate is a negotiation among internal heat, blanket gases, and radiolysis by cosmic rays. Hydrogen-rich mantles can push deep tropospheres to temperate pressures and temperatures even in darkness, add tidal needing every few months, and a subsurface ocean becomes not just likely but vigorous. Life, if it cares only for gradients and solvents, could regard the whole nebular conurbation as a sky it never needs. Metabolism chews on oxidants laid down in storm seasons and waits out the cold. Biosignatures would be pericenter phasic, bursts of trace gases that rise, react, and fall on a schedule written by gravity, not daylight. The surrounding star-packed burrow never stops meddling. Resonant relaxation nudges orientations. Causative pumping from the wider cluster can trade inclination for eccentricity, occasionally pushing a survivor into the red line where one more degree of freedom means disassembly. Passing compact remnants, neutron stars or small black holes, offer impulsive kicks that can flip the ellipse or eject the traveler altogether into the deeper halo of the stellar commonwealth. Thin streams of gas drifting like pale smoke near the core can sap energy at some true anomalies and donate it at others, herding small bodies into families with shared pericenter directions, ghost belts that a sensitive telescope might map as repeating arcs of dust. Endgames are varied and theatrical. The unlucky shred into a luminous noodle, the modest settle into warm embers that paint the inner flow with fine solids, the rare bold few spiral inward over eons as tides and drag eat angular momentum, flirting with orbits so tight that relativistic beaming would turn the world's nightside into a time-varying lighthouse. Somewhere in the ledger of this deep sky province there must be a limit case, a super-Earth that schemes just outside the last stable path, lit not by a nearby lamp but by spacetime's violence, wearing auroras brighter than continents and an ocean that boils sideways only 1 week in every 100. That, too, is a planet, night-bound, time-scarred, tide-fed, owed to the same rule the whole stellar federation obeys: fall toward the deepest place you can find, and call whatever survives a home. Over long stretches the captured world becomes an archivist for the whole Star City's center. Each near miss with the abyss writes separate, datable layers, a veneer of nitrates frozen after one bright storm season, a cracked dike where tidal heating forced magma into brittle rock on another loop, a lacy deposit of tholins laid down when ultraviolet flares ran especially hot. Ice shells remember in stratigraphy, rocky crusts remember in stress shadows that only relax during the far-out winter. Even the core keeps time, because tides pump energy at discrete harmonics of the orbit and those harmonics drift as relativity slowly rotates the ellipse. A geophysicist dropping a seismometer here would be reading the ephemeris of spacetime, not the calendar of a sun. Close Passage has its own weather. The planet plows through dilute but angry plasma threaded by magnetic fields, the flow wraps into a comet-like magnetotail and a bow shock grows ahead of the nose where neutral exosphere gas meets relativistic wind. Sputtering and charge exchange carve atoms from the high atmosphere and turn them into a faint, elongated cloud that the next orbit shears into a filament. If the globe carries rings, ram pressure kinks their edges and differential precession winds them into spirals. Self-gravity and collisional damping then rebuild order between passages, like a record that warps in heat and then flattens under its own weight. Moons complicate everything in beautiful ways. A small companion can pump the big body's eccentricity, modulate tidal heating on beat frequencies, and see transient arcs of dust that flare in forward scattered light as the pair schemes the inner glow. Energy bookkeeping sets the long arc of fate. Tides within the world steal orbital energy and stash it as heat. Tides raised on the central giant don't matter, but tides raised by the planet on itself do. The conversion efficiency depends on the love number and quality factor, how deformable and how lossy the body is. Rubbery ice shells and partially molten mantles turn orbit into warmth better than rigid iron. In dusty inner gas, hydrodynamic drag dozes along, shaving a little velocity each pericenter. Over many circuits, the path shortens and rounds, the pericenter lifts, and the heating softens. Some refugees eventually settle into warm, near-circular tracks in the inner glow where they become stealth heaters of the local medium, shedding fine solids that drift inward and thicken the luminous fog. Others never calm down. A perturbation from a passing remnant or a secular push from the surrounding cluster ratchets the eccentricity upward until the safe corridor narrows to nothing and the world shreds into a ribbon. The ribbon stage is its own astronomy. Tidal debris lifts into a thin stream whose inner parts race ahead and outer parts lag, where the loop closes on itself, self-intersections shock and light the gas, and a broken ring forms that slowly feeds the central engine. Dust grains sputtered from the stream pick up charge and feel Lorentz forces, painting the inner precinct with faint, polar-aligned brushes. If any of that debris crosses our line of sight to a bright background tracer, the light curve would show multiple, sharp-edged dimmings spaced by the stream's thickness and the ring's precession. The geometry would be a decoder ring for the mass and spin of the core and a post-mortem for the world that didn't make the cut. Between catastrophes, biology has room to try things. A hydrogen-rich cloak can push the deep atmosphere to temper pressures even in eternal night. Add ammonia, methane, and water and you have a chemistry set that resets at each fiery swing but never fully erases. In an ocean sealed under ice, pressure-induced clathrates and antifreeze salts can keep brine liquid while tides stir it like a slow piston. Oxidants laid down during auroral seasons diffuse into the dark and feed redox metabolisms that care about gradients more than skylight. If anything living evolves timing, if enzymes anticipate the hot week by upregulating repair pathways and membrane chemistries before the plunge, it would be a life that reads gravity as weather and relativity as calendar. Signals for telescopes must be chosen where the contrast is kind. Thermal emission is honest. Pericenter spikes in the mid-infrared, decays over days to weeks with a tail set by heat capacity and circulation, and returns on schedule with a phase that creeps as the ellipse rotates. Polarization is a second handle. Forward scattered dust from a transient ring produces a polarized flash that peaks slightly before the thermal crest, and the offset grows if the ring is tilted by frame dragging. Low-frequency radio from unipolar induction sets a clock that jumps when the magnetosphere reconnects. Line emission from sputtered neutrals, oxygen, carbon, sodium, traces the exosphere's size and tells whether the atmosphere is being eroded or merely roughed up. A handful of orbits, modeled together, would weigh the central anchor, test for spin-induced nodding, and even hint at the traveler's interior through how quickly it turns orbit into heat. Capture demographics are written by the wider star continent. Barred systems funnel gas toward their hubs, thickening the medium and boosting drag capture for pebble-to-comet scales, while rich nuclear clusters elevate the rate of three-body exchanges that can swap planets off their host lamps. Ellipticals with giant central engines have bigger safe lanes for rocky bodies. The event horizon is larger but the tidal radius scales more slowly, so some retain captured super-Earths that skim within a few tenths of an astronomical unit of the rim and light up like lanterns at each dive. Dwarfs with small cores are harsher. The tidal radius shrinks until rock must venture so near that survival becomes unlikely and ribbons are the rule. Different neighborhoods breed different fossils. Navigation through this inner ward is a textbook in subtle torques. Resonant relaxation trades angular momentum among orbits with similar energies, random walking the orientation in a way that can be faster than two-body scattering. Correlative cycles from the broader cluster tilt and stretch paths, sometimes stalling at high inclination where pericenter distances hover near the danger line for long intervals. Spacetime itself adds Lady's handwriting on top, apsidal advance from curvature, nodal drift from spin, tiny extra twists from the quadrupole moment if the central spinner is not a perfect sphere of gravity. Track those twists carefully enough and you are testing that no-hair statement with a planet as your pen. Material properties decide microscale outcomes that telescopes can, in principle, see. A silicate globe with a thin atmosphere radiates heat in sharp pulses and shows strong orbital harmonics. An ice-rich body wears a deeper thermal memory and peaks later and longer. A mini-Neptune with a puffed hydrogen shell shows broad, muted crests with photochemical afterglows that last into the cold months. Magnetic moments matter. A strong dynamo breeds radio bursts and fierce auroras. A dead core leaves only the sputtered exosphere and dust. Rings survive if self-gravity and collisional damping can beat differential precession. If not, they dissolve into transient spirals that recur each hot season. Moons persist if their hill spheres stay intact at pericenter. If the line tightens too far, satellites are peeled away into their own brief, beautiful lives as inner debris. The violence of closest approach also forges minerals that elsewhere need deep crustal ovens or large impacts. Shock veins freeze into masculinite-like glasses, high-pressure ices build and unbuild, iron sulfides rearrange, nitrides and cyanides condense in the upper air and snow out as brittle films that crackle electrically under auroral rain. Meteoroid environments spike because the inner precinct is dusty and many bodies share similar paths. Impacts prefer the weaks near pericenter, so craters cluster in longitude and carry vitrified splashes that betray the direction of the plunge. One can imagine reading, centuries later, a run of closely spaced microcraters on a rover's hull and inferring the exact argument of pericenter that year. Some refugees find a loophole. Mean motion resonances with other small bodies near apicenter can freeze the pericenter distance at a safe value even while the rest of the ellipse precesses. Those resonant shepherds form ghost families, swarms that share a preferred closest approach and, viewed edge-on, draw repeated arcs in scattered light inside the central glow. Others are guided by gas. Weak, steady drag can herd populations into narrow corridors of phase space, the way snow fences cause dunes. In a richly fed nucleus, these soft forces can outweigh random kicks, creating long-lived belts of invisible worlds that announce themselves only by their synchronized heating. Push the parameters to their limit and stranger scenes appear. A super-Earth returns again and again to a pericenter a few dozen solar radii from a spinning colossus. Relativistic beaming of the central halo makes the sky brighten anisotropically during each dive, and the horizon's photon ring smears into a bright, offset hoop that slides across the planet's night side like a slow searchlight. The globe's deep mantle stays partially molten for geological ages. A carbon-rich atmosphere builds photochemical suits that collapse into brief, oily rains. Ocean under ice worlds vent towers of vapor at the hot season and lay down thick hoarfrost at aphelion, a respiration visible in the infrared from 500,000 light-years away. None of this requires a daytime or a lamp, only a deep well in time. From afar, this starry republic's core looks calm, a soft glow, a few brilliant flares, a ballet of fast stars. Under that calm is a census of hidden citizens, worlds that chose gravity over daylight and learned to live by a different clock. They carry seismograms of curvature in their crusts, auroral scars in their skies, chemistry written by radiation instead of sunshine, and histories punctuated by tides rather than seasons. Call the host what you like, the spiral realm, the island of suns, the luminous federation. The rule at its heart is simple and absolute: fall toward the deepest place, learn its rhythm, and if you can, make a life there. Say the word and we can chase one traveler through a full year of its impossible orbit, from the far dark to the furnace and back, reading in every glow and crack how a planet becomes a chronometer for a gravity well. Take one full circuit and stretch it into a diary. Far out in the cold quarter of its path, the night-bound globe drifts through the quiet suburbs of the stellar polis, where the crowd noise of the central district is only a rumor. The sky is a powdered salt of distant lamps. The great dark turbine is just a smudge of high-energy frost, brighter to instruments than to eyes. Here the planet breathes slowly. Convection cells in the mantle climb and fall without hurry. Tidal stress is a background hum, and any ocean beneath ice turns over on month-long loops, not minutes. The atmosphere, if one exists, reaches chemical standstill, radicals quenched, haze is settled, trace gases partitioned between air and brine. Animals, if any, evolve to match gradients rather than daylight, idle and store energy like desert seeds after a rare rain. Approach begins as a whisper in the crust. Tidal harmonics strengthen, first as a soft beat riding the planet's rotation, then as a clear rhythm that tides can lock to. Faults unglue at predictable longitudes, cryovolcanic throats pressurize, ring particles march into spiral density waves that a low orbiter could count like grooves on vinyl. The sky brightens in a way that no childhood teaches, not from a rising lamp, but from a whole quadrant growing milkier as the inner halo of the central dynamo swells with Doppler-boosted light. Magnetic drapery thickens around the planet's moving obstacle, the bow shock intensifies and the magnetotail lengthens, beating with reconnection sites that pop like underwater welding. Midway through the plunge, induction turns the world into a generator. Motion across the core's tangled field drives currents that close through the ionosphere and the interior. Joule heating adds to the budget, auroral ovals widen and split. The spectrum hardens. X-rays punch chemistry into pieces, ultraviolet scribbles nitrates into the high air, and charged particles dive down field lines to seed odd nitrogen and peroxides that will sink into oceans weeks later as slow oxidant rain. If the cloaked traveler is a sub-Neptune, the puffed hydrogen mantle cools and expands at altitude even as deeper layers warm. If it is rocky, the daytime that never comes is replaced by thermal bruises, hotspots set by stress rather than sunshine, that drift under jet streams like continents of fever. Closest approach arrives as geometry, not sunrise. The horizon wears an offset ring where photon paths graze the rim of the abyss. The ring slides across the night side like a slow, luminous hula hoop, brightening and dimming with relativistic beaming as the inner flow rotates. Gravity is now a sculptor you can feel in your bones. Mountains shrink elastically by millimeters and rebound, deep rock nears its yield. In ductile layers, strain localizes into shear zones that light up with microscopic melts. In brittle caps, aftershocks ripple in trains. An ocean sealed under ice goes tidal like an organ pipe, pressure waves ring, frazzle crystals churn, and brine plumes bloom into temporary chimneys that exhale warmth and trace gases. If the globe wears rings, ram pressure kinks their rims and nodal precession tilts them a few degrees. If it carries a moon, the satellite's Hill sphere pinches, and the little companion loses dust to a faint arc that will be sheared into a filament before the next far winter. Pericenter is also a laboratory for relativity. The track is not a closed ellipse but a petaled rosette. After each dive the argument of pericenter jumps forward, so the next furnace week arrives at a different longitude. If the central spinner's axis is tilted, the orbital plane nods, and the ring's shadow at pericenter swings year to year like a sundial that reads spacetime. Those tiny geometric shifts are clocks. Fold the mid-infrared light curve on the nominal period and watch the peak creep, map polarization spikes from forward scattered dust and see them march relative to the thermal crest, time radio bursts from induction and measure the beat as the plane precesses. Put those beats together and you weigh the central anchor, gauge its spin, and sketch its quadrupole, the way a bright S-star does, but with a cold, small, stubborn pen. After the whip, recovery. The plasma thins, radiation softens, the bow shock retreats, aurora dim to ghostly caps. Chemistry keeps momentum, nitrates rain out, peroxides and NOx burrow into brines, polymer haze snow settles like a dirty hoarfrost that later sublimates from the subpolar basins. Thermal inertia writes fat tails into the light curve, a rocky globe's emission drops fast, an ice-rich world lingers, a mini-Neptune smears the peak into a broad shoulder with photochemical afterglow. On the ground, or under it, ecosystems, if they exist, pivot from repair to metabolism, spending the oxidants banked during storm week. Tidal heating falls back to background, but not to zero. The interior remains warmer than any starless night would allow, and over geological spans the cumulative budget rivals small moons in ordinary planetary systems. Zoom out to the host to see why these stories differ across neighborhoods. In a barred stellar province, gas lanes feed the hub and thicken the medium, aerodynamic capture favors pebble to comet scales and shepherds small worlds into families with a shared pericenter direction, ghost belts that paint repeated arcs of faint dust inside the central glow. In a giant ellipticals downtown, the central engine is heavier and the safe corridor for rock is wider. Captured super-Earths can skim close, survive, and become periodic heat lamps that season the inner fog with solids. In dwarfish capitals with lightweights at the core, rock must dive too near for comfort, ribbon-making events dominate, and the inner precinct wears transient, shock-bright rings that wink on and fade as streams intersect. The same dynamical census that sets how often bright flares occur also sets how many hidden citizens ride rosettes instead of going to ribbons. Instrumentation chooses its battles. Mid-infrared timing favors the cadence of heat, sub-millimeter ears listen for cyclotron maser bursts from induction, optical polarimetry hunts the small, highly polarized flashes from forward-scattered dust arcs. High-resolution spectroscopy targets alkali lines, sodium, potassium, broadened by pressure and seasoned by sputtering, while neutral oxygen and carbon glow in forbidden lines that tell how much exosphere is being gnawed away. Precision astrometry in the inner parsec catches tiny, correlated tugs on nearby tracers. Even if no single world stands out, a population adds texture to the dance that a patient interferometer can untangle. Future low-frequency space antennas might someday hear the soft gravitational murmurs of the tightest, most massive survivors, a planet-scale extreme mass ratio whisper mapping the deepest contours of the central well. Material strength, not just mass, decides the microphysics that telescopes can read. Silicate skins radiate sharply and crack loudly, ice mantles store heat and exhale slowly, hydrogen cloaks mute peaks and lengthen tails. Strong dynamos blare in radio and paint brutal aurora, dead cores go quiet except for sputterglow and dust. Rings persist if self-gravity and collisional damping beat differential precession, otherwise they dissolve and reform on each hot season, leaving a repeatable barcode of tilted spirals. Moons last if their spheres of influence survive the pinch at closest approach, otherwise they peel off into temporary arcs and then into nothing, contributing a faint, periodic drizzle of grains to the inner haze. Even failure leaves knowledge. A shredded world becomes a thin, phase-wrapped stream, where the loop self-intersects, shocks light the gas and sculpt a broken ring whose precession rate encodes the mass and spin of the core. Charged grains from the stream drift under Lorentz forces into polar brushes. If those cross the line of sight to a bright background tracer, the light curve fractures into a set of knife-edged dips that step with the ring's thickness and twist with its knotting. Read those dip trains long enough, and you reconstruct the geometry of a place that cannot be visited, only inferred. What looks from far away like a calm ember in the middle of the star archipelago, one soft glow, a few flares, a fast ballet of test stars, is in fact a city center with weather. Hidden among its traffic are worlds without dawns that keep time by curvature, store heat from tides, and write their calendars in layers of glass, salt, and ice. They exchange daylight for deep well discipline and find ways to live by it, by chemistry that resets instead of cycles, by oceans that breathe to a relativistic beat, by rocks that remember the angles between gravity's petals. Call the host what you wish, the spiral dominion, the luminous burrow, the island of suns, the stellar commonwealth. Its law is simple and welcoming to any drifter. If you can fall and not unmake yourself, you can belong. Modelers sketch the corridors where survival beats shredding by writing down the simplest balance they can and then adding the necessary sins. The tidal radius scales as the planet size times the cube root of the mass ratio. Set that against the closest approach and you get a pass/fail strip in phase space that widens for ices and narrows for iron. Layer on viscoelastic dissipation and that maybe region fattens, because worlds that flex and heat also bleed orbital energy and lift their pericenters over thousands of loops. Around a modest central colossus, millions of suns, the safe lane for rock sits outside a fraction of an astronomical unit. Scale the engine up by 1,000 and the same world can skate far closer because the gradient softens. That counterintuitive truth means giant ellipticals in the constellation capital may keep more intact wanderers, while tinier cores in drowsier townships make ribbons as a rule. Rates matter, and the Star Republic's downtown is generous. Nuclear clusters seed three-body captures whenever a star-planet pair grazes the central well. Roughly one in many thousands of plunges will park the smaller companion on a needle ellipse while the lamp is flung outward, dazed but bound to the greater burrow. Rogue supply is not an issue. Galactic disks eject planets by the billions over cosmic time through migration mishaps and dynamical brawls. The central precinct, with its thick crowd and drifting gas, sweeps a share of those drifters into membership. Add weak aerodynamic drag from hot plasma and a slow rain of tiny energy losses at each dive, and a fraction of passers-by trade visitor badges for residency. The metropolitan sum is not a handful of exotica but a shadow population, countless cold citizens tracing rosettes that no ordinary eclipse will ever reveal. Observation strategies read like scavenger hunts. In the spiral confederation closest to home, the inner parsec is already mapped in moving dots. Amplify that precision and a planet mass tug becomes visible as correlated wiggles in the paths of faint tracers. In the nebular city-state farther away, timing wins, mid-infrared light curves that crest on schedule and creep in phase with relativistic advance, sub-millimeter spikes from induction-driven aurora that sharpen near pericenter, polarized flashes from forward-scattered dust arcs that precede the heat peak by a predictable offset if rings tilt under frame dragging. High-resolution spectra taken during the hot week look for broad alkali lines from a puffed exosphere and faint forbidden oxygen that tells how much atmosphere was gnawed away. Stack multiple orbits and the geometry falls out, mass from the period and amplitude, spin from the knotting of the plane, quadrupole from the rate at which the petals open. Climates on these nightbound worlds learn to budget like miserly accountants. Hydrogen-rich mantles build deep, warm tropospheres by collision-induced absorption. Tides inject heat spikes that circulation smears horizontally, while vertical mixing ferries oxidants from auroral caps down to dark oceans. On rocky bodies, partial melts rise and stall as sills, glassing over between passages and preserving a palimpsest of furnace weeks. On ice giants, ammonia, water brines maintain conduits that open during pericenter and pinch shut in the far winter, a respiration that leaves textural bands readable by any lander that ever learns to break in such a sky. Chemistry never settles. Radicals made aloft during the storm week diffuse for months and finish their reactions in places sunlight never finds, so redox cycles are written by orbit phase, not diurnal pattern. If life appears, it would likely hoard enzymes that pre-activate repair pathways before the plunge and hibernate in the long coast, treating gravity as weather and spacetime as calendar. Magnetism carves signatures loud enough for distant ears. Motion across the central field drives Alphane wings that link the world to the glow. The unipolar inductor model predicts radio bursts whose frequencies trace the local gyro frequency and whose power scales with the square of the relative speed. Those bursts should cluster near true anomaly windows where the planet slices across strongly magnetized streams and where reconnection tears the tail. The induced currents heat the ionosphere, coupling into neutral winds that, in turn, shift where auroral chemistry writes its nitrates and peroxides. A strong native dynamo multiplies the effect, caging charged particles and staging auroral crowns so bright that even the muted night side would flicker in false dawns. A dead core does not go silent, it sputters, but its radio is thin, its aurora ghostly, its chemistry slower. Rings and moons become reporters almost against their will. Ram pressure hums at pericenter, kinking ring rims and launching spiral density waves whose wavelengths encode the local gravity and the drag the particles feel. Differential precession twists those patterns into barcodes that, read over successive passes, reveal how the orbital plane nods and how the petals of the rosette open. Satellites survive only if their Hill spheres stay generous at closest approach. In border cases, a moon is peeled into a debris arc that flashes in forward scatter and then is ground into a filament, the timing of that flash relative to the thermal crest pegs how close the peel happened. Rarely, a resonant partner at apicenter can hold the pericenter distance steady despite all the other torques, ghost shepherds that keep a family of worlds alive by freezing the dangerous angle where tides would otherwise squeeze too hard. Shredding is not a coda but a chapter. Cross the narrow line and the traveler lengthens into a stream, inner segments rush ahead, outer ones lag, and when the loop closes the self-intersection shocks light the gas and slap the dust into a broken hoop that precesses. Charged grains in that hoop drift along field lines, painting polar brushes. If a bright background tracer schemes behind, the light curve suffers a stack of razor-edged dips spaced by the ring's thickness and shifted by knotting. That signature is a decoder for the mass and spin of the central engine and a postmortem for the world that failed the corridor by a cruel percent. Everything scales, so the constellation Commonwealth writes variations on the theme. In a metropolis where the core is heavy and fed, the photon bath at 1 astronomical unit during flares rivals noonday on ordinary worlds. Volatile skins boil, haze factories roar, and dust wakes are certain. In a quieter burrow with a leaner engine, radiation sculpts chemistry without much heat. Atmospheres thicken with polymers and nitriles that snow in the months after pericenter and sublimate again next year, painting a seasonal loop with no sun involved. In barred provinces, gas lanes favor drag capture and then herd survivors into belts with shared pericenter directions. In dwarf townships, the safe corridor is so narrow that the inner haze is continually refreshed by fresh ribbons and the dust arcs are young and bright. If intelligence ever rides one of these rosettes, its engineering would look nothing like the lamp worship of ordinary civilizations. Energy arrives in predictable surges from tides and induction. Heat sinks are the great dark. Line-of-sight backlights are everywhere thanks to the lensing hoop. Power grids would learn to drink the hot week and sleep the far winter. Chemistry labs would time their radicals to the auroral rain. Observatories would treat the photon ring as a calibration lamp sliding across the sky. Technosignatures would pulse with the orbit, waste heat that crests near pericenter but lingers longer than geology alone would allow, coherent radio that rides the induction bands, artificial haze clearing patterns that oppose photochemical production. Even without such contrivances, the natural cadence is generous enough to find with patient instruments and an appetite for the subtle. From the high balcony where we name things, the luminous Federation is just another galaxy, a smear with a bright heart. From the level where orbits scrape physics raw, it is a workshop for worlds that swap daylight for a deeper rule. They keep ephemerides in glass veins and salt layers, promise their storms by geometry instead of sunrise, and add their quiet, periodic breath to the glow that marks the center of the starry union. Call that host a spiral precinct, a stellar dominion, a city of lamps, names or costumes. The law underneath is always the same: if a wanderer can surrender just enough energy without surrendering itself, the core will make a citizen of it, and the rosette will do the rest. Spin is the quiet conspirator that decides how a captured traveler ages. Tidal torques try to lock rotation to a resonance with the orbit. The target is not a friendly 1:1 like ordinary moons but a shifting compromise, because the planet spends almost all its time creeping and a few days sprinting. Many worlds settle into chaotic tumbling with preferred states near 3:2 or 5:2 between spin and mean motion, then hop when the pericenter precession drifts the forcing frequency. Obliquity is not a noble constant either. Close approaches yank the spin axis, and any liquid core or subsurface ocean acts like a gimbal that lags behind the torque, turning each dive into a small, cumulative tilt. Over thousands of loops the interior picks a rheology to live by, Maxwell-like if warm and wet, Andrade-like if crystal lattices dominate, and that choice sets how efficiently orbital energy becomes heat. A rubbery ice shell with a relaxation time of hours answers the tide like a drum. A glassy mantle with a relaxation time of years takes the punch late, smearing heating into the coasting months and rewriting the thermal light curve. Escape is a ledger with two columns, thermal and non-thermal, and pericenter pays both. In the hot week, X-ray and ultraviolet photons pump the thermosphere until the exobase swells. If the binding energy per particle is low enough, a hydrodynamic wind lifts off and mass loss goes energy limited, proportional to the incident high-energy flux and the cube of planetary radius divided by the mass. Where photons cannot finish the job, particles do. Charge exchange and sputtering knock heavy atoms free, and pickup ions carry them down the magnetized flow. Hydrogen cloaks survive by sheer inventory. Rocky air survives by molecular weight and by hiding in cold traps between dives. Mini-Neptunes walk a line where a few 100 million years of furnace seasons can peel their outer envelopes and leave warm super-Earths with photochemical scars. Every lost kilogram is a page torn from the future chemistry set, and yet those very losses write signals in sodium and potassium lines, in far ultraviolet oxygen glow, and in radio whispers from pickup currents that a patient telescope can count. Surface processes answer on their own clocks. On rock, tidal quakes stitch dense networks of microfaults that creep at aphelion and unlock at the plunge. Veins of high-pressure minerals freeze in milliseconds, glassing in tracers of stress direction like arrows on a map. On ice, brine channels anneal into fabrics that remember the last dozen hot weeks. As convection strengthens, diapirs of warm, salty ice rise, stall, and leave pitted plains where they breached, features that would be mistaken for cryovolcanic calderas anywhere else. If a carbonaceous crust lies shallow, ultraviolet at pericenter cooks polyaromatic residues that darken the surface and steepen thermal contrasts. When the planet coasts back into darkness, those contrasts drive katabatic winds under a starless sky, lofting dust that seeds the next season's hazes. A world with even a modest biosphere would treat these pulses as festival and famine. Enzymes timed to the electrical season would pre-arm repair pathways, membranes would stiffen against peroxides, and metabolic networks would bloom when oxidants rain out and sleep when the pantry runs low. The central engine's demeanor matters, and hubs across the Starlight Republic offer a spectrum of moods. In a well-fed downtown, the inner flow is thick, the photon bath is bright, and the magnetic topology changes on human timescales. Captured citizens see furnace weeks that rival noons on ordinary worlds and induction storms that light polar skies like continents. In a leaner precinct, the glow is hard but faint, chemistry is carved more than cooked, and atmospheres evolve toward heavy, stubborn mixes that weather the years by polymerizing aloft and raining thin films that crackle under weak aurora. In barred provinces, Gas lanes see gentle drag that rounds orbits and herd survivors into belts with shared closest approach longitudes. In dwarf cantons with lightweight cores, survival lanes narrow until stone must flirt so close to the rim that ribbons outnumber rosettes and the inner haze is young and constantly replenished. Crowds breed resonances, and even worlds that never meet change one another. Near apicenter, mean motion commensurabilities trap pairs into exchanging angular momentum on slow beats that keep their pericenters from wandering into danger, a mutual aid society of invisible citizens. Farther in, secular resonances tied to the precession rate of the whole cluster can pump inclinations while damping eccentricities, trading plunge risk for tilted loops that paint the inner glow with high-latitude dust. Occasionally a compact remnant on a plunging track kicks the dice. A brief, strong encounter flips a survivor's orbital plane or nudges eccentricity over the safe line, and a future hot week becomes the last. If a moon or ring was along for the ride, its fate becomes a timestamp, where in the orbit the peel happened, how thick the arc became, which way the spirals were twisted by nodding, clues preserved in polarized flashes that arrive like punctuation before the thermal crest. Detection strategies reward stubborn watchers. Mid-infrared timing remains the anchor, because heat tells the truth, peaks that recur on schedule but creep in phase as the pedaled path advances, widths that diagnose heat capacity, tails that separate ice from rock from gas. Low-frequency radio, if caught, gives sharp hooks to hang models on, auroral bursts that map gyrofrequencies and therefore field strengths in the flow, reconnection crackles that clock the magnetotail's geometry, quiet intervals that reveal when the planet is gliding along field lines instead of cutting across them. Optical and near-infrared polarimetry hunts for small, highly polarized flashes from forward-scattered dust and transient rings. Spectroscopy during the hot week chases broadened alkali lines and faint oxygen-forbidden lines, while submillimeter ears listen for continuum bumps from warm dust wakes. Stack a handful of orbits, fold by the changing period, and the central mass drops out. Track the nodding of polarization peaks relative to thermal crests, and spin follows. Measure the rate at which the peak time drifts, and the quadrupole peaks through, a test of whether the dark turbine's gravity is as bald as the no-hair dictum insists. Engineering thought experiments sharpen the picture. A civilization riding such a path would build grids that charge on tides and induction, not sunshine. Heat sinks would be the deep night. Observatories would use the photon ring as a moving calibrator sweeping the horizon each furnace week. If they farmed chemistry, they would time reactors to the oxidant rain and pipe brines through porous rock when tides are high. If they signaled, their waste heat would crest too symmetrically unless they intervened. Their radio would ride the induction bands where nature also shouts. Their haze would clear with a phase that fights photochemical production. None of that is necessary to make the case, but it means techno-signatures here would be periodic, geometry-locked, and layered atop a cadence written by gravity itself. The most fragile chapters leave the crispest tracers. When a traveler misjudges the corridor and lengthens into a stream, the broken ring that follows precesses like a slow metronome. Each time it crosses itself, shocks brighten and the inner fog glows in arcs. Charged grains drift into polar plumes aligned with the big field. If those brushes pass in front of a bright background tracer, the light curve steps down and up with knife edges that repeat with the ring's thickness and nod with the plane's drift. Read a few seasons of those steps and you can reconstruct the ring's tilt, the precession rate, and therefore the central spin, an autopsy that doubles as a map of the deepest gravitational contours in town. All of this turns the luminous Dominion's core from a decorative spark into a laboratory where worlds trade daylight for a stricter rhythm. The captured citizens keep clocks in glass veins and salt bands, write calendars in auroral nitrates and polymer frosts, and evolve climates that answer to pericenter rather than noon. They make the inner haze thicker or thinner, they see dust arcs that whisper in polarization, they flex into heat that leaks back out as infrared that anyone with patience can time. Call the host a stellar municipality, a radiant conurbation, a republic of lamps, a city of suns. The name is a label on a law that does not change. Fall toward the deepest well you can find, spend energy to survive the closest pass, store the memory in stone and ice, and come around again on schedule until a kick ends the story or the orbit rounds into a quieter life. Over time, the electricity of motion writes architecture across the traveler's skies. Alphane wings tether the globe to the inner glow like invisible guy wires, where those current systems close through the ionosphere. Narrow jets of neutral wind spin up and carve long-lived channels in the upper air. Those lanes become the preferred highways for photochemical products after each furnace week, so nitriles and peroxides migrate along repeating great circles that a spectrograph could map as season-locked ribbons. If the world's dynamo is strong, induction pushes it toward a quasi-steady state in which the ionospheric Peterson conductance increases during the plunge, raising the Joule heating fraction and shifting the thermal crest slightly earlier than tides alone would predict. That phase lead is small but diagnostic, a few degrees in true anomaly that separate an ice mantle from a rock mantle, a dead core from a living one. Spin evolution never stops negotiating. Warp-like torques appear even without a sun because the radiation field near pericenter is anisotropic and the surface emits heat with strong longitudinal contrast. The net recoil from that uneven thermal glow nudges rotation rates over many loops. Add a lopsided ring or a triaxial shape and the planet's tumbling becomes a slow walk across resonances, with brief windows of apparent stability followed by chaotic flips when the pericenter advances into an unlucky geometry. Obliquity tides couple to this dance, pumping energy most efficiently when the spin axis hovers near certain tilts. Worlds can self-tune into these hot tilts and then drift away again as the rosette opens petal by petal. Rings tell their own patient story. Pointing, Robertson drag and plasma drag both act at pericenter, shortening particle semi-major axes in bursts. Between dives, collisional cooling and self-gravity shepherd the debris back toward narrow bands. Differential precession under the central quadrupole twists those bands into repeating spiral barcodes. Frame dragging adds a slow nod that lifts and lowers the pattern against the planet's equator. Read that barcode over a handful of orbits and the central spin sign, prograde or retrograde, drops out, along with a crude measure of its magnitude. If a small shepherd moon survives, its wake carves scallops whose spacing fixes the moon's mass. If the moon is peeled during a particularly hard season, the sudden loss imprints a sharp change in the ring's optical depth that becomes a timestamp for the corridor's narrowing. Geophysics turns the orbit into mineralogy. At pressures found a few hundred kilometers down, silicates cross phase boundaries that sequester water and carbon differently. Pericenter pulses can drive short-lived dehydration or decarbonation fronts that move upward as waves. Those fronts leave glassy, volatile pore veins frozen on minute timescales, an igneous Morse code that records not weather but geometry. In ice, clathrates form and fail on the march. Methane clathrate cages build between dives and collapse when pressure drops in tidally pumped fractures, venting plumes that paint nearby snow with dark organics before the cold winter seals the holes. The cumulative effect is a crust that looks like it endured alternating impact epochs and volcanism, except the spacings are clockwork and the provenance is gravity, not randomness. The radiant municipality that hosts this all furnishes backlights for free. The photon ring is a moving calibration lamp. Background stars in the inner arcsecond of the hub are plentiful. Filaments of ionized gas thread the district like neon signs. A transient dust wake from the traveler, viewed against any of those backgrounds, polarizes light by forward scatter. Polarization degree and angle peak slightly before the thermal crest, and the offset grows if the orbital plane nods from the core's spin. In an observatory's ledger, that means thermal phase curves in the mid-infrared to anchor the heat, polarimetry in the red and near-infrared to time the dust flashes, sub-millimeter monitoring for induction-driven cyclotron masers, and high-dispersion spectra around the sodium and potassium doublets to catch puffed exospheres broadened by pressure and stirred by sputtering. Stack a few orbits, fold by the creeping period, and the mass, spin, and quadrupole of the central citadel arrive without a single eclipse. Population thinking turns anecdotes into a census. Disks fling out wanderers by the billions, nuclear clusters in star archipelagos run three-body exchanges as a matter of course, gas lanes in barred provinces thicken the medium and make aerodynamic capture plausible for anything from gravel to icy dwarfs. The capture cross-section for planet-star pairs grazing a central engine scales with the density of binaries and the velocity dispersion of the downtown, both rise toward the core. Even if only a sliver of encounters end in residency, the steady supply over gigayears implies a shadow population, cold citizens on eccentric rosettes, a minority shredded into ribbons, a smaller minority circularized into warm, dim embers that seed the inner fog with dust. Their integrated effect may already be in our data as excess, phase-coherent variability and faint, repeating arcs inside the central glow that no supernova remnant quite explains. Habitability, stripped of daylight, becomes a question of budgets, shields, and timing. A hydrogen ocean under a heavy sky can sit at room temperatures at depth even in the long coast, with convection closing the loop between the oxidants laid down by aurora and the reductants percolating from hydrothermal systems pumped by tides. Life that evolves in such a place would not use diurnal cycles, it would train to the furnace week, pre-arming DNA repair, switching membrane chemistry, and hoarding or dumping antioxidants on schedule. Biosignatures, if they ever escape, would be orbital, trace gases that spike in a predictable phase window, spectral albedo changes from transient films laid down after pericenter, maybe even faint, periodic radio quieting if a biosphere learns to ride the induction weather rather than fight it. None of that is necessary for the physics to sing. It is simply what chemistry and time allow when geometry runs the clock. Push the parameters and the constellated republic answers with extremes. Around a truly massive central sovereign, the tidal radius for rock ducking inside the photon ring is still outside the horizon, so an iron-heavy super-Earth can skim perilously close and live. Relativity then dominates the narrative, smearing the sky with beamed light and nudging the thermal crest forward with each pass. Around a lightweight core in a dwarf canton, the safe corridor shrinks until pericenter heating and ram pressure cross into demolition, so ribbons are common and broken rings press like slow metronomes that modulate the inner haze. In gas-rich capitals, drag capture rights families with shared closest approach longitudes. In austere districts the survivors are those that lucked into long-lived resonances that freeze a safe pericenter while everything else precesses. From a great remove, the island of suns is still just a soft flame in a dark room. Up close, its downtown is busy with hidden citizens who learn to keep time by curvature. They carry auroral scars instead of sunsets, store heat in tides instead of summer, and write their history in glassy veins, salty bands, polarized flashes, and infrared breaths that recur on schedule. They turn a galactic hub, this spiral ward, this luminous arrondissement, this stellar capital, into a metronome. And the rule that admits them is spare and merciless and strangely generous. Give up the right amount of energy in the right place, pass the corridor without unthreading, and you may trade daylight for membership, returning again and again along a pedaled path that only gravity could draw. The sky above such a traveler is never the same twice, and the differences are not weather so much as geometry. As velocity climbs, aberration drags the whole firmament forward, background stars crowd into a bright wedge, their spectra Doppler shifted blue while the opposite sky thins and reddens. Lensing adds a second trick, as the globe sweeps through changing impact parameters, caustic scrawl faint, moving arcs across the heavens, brief mirages of remote suns folded by curvature. Near the razor-close segment, the photon ring of the central citadel brightens into an offset hoop, its brightness modulates with the spin of the inner flow, and its position creeps from year to year as the rosette opens. With a small telescope and patience, inhabitants, if any, could treat that hoop like a drifting metronome, calibrating clocks and long baseline interferometers by a light that is not a lamp but a path. Beneath that shifting dome, heat does not come from a hemisphere but from a harmonic. Degree, two tides paint twin warm lobes that chase the subpericenter longitude, viscosity decides whether the crest leads or lags the stress. In a soft ice shell the peak arrives early and smears into a broad belt, in glacier rock it arrives late and tall, a thermal bruise that slides under jet streams. The circulation it drives is alien to sunlight worlds, superrotation born from longitudinal pressure contrasts, gravity waves that break where tides focus, and atmospheric tides that resonate with the body tide to amplify or mute heating by small phase shifts. Couple that to a magnetic crown and the result is a three-layer energy ledger, Joule heating aloft, tidal dissipation below, and advective work in between, that writes telltale offsets into the mid-infrared phase curve. Chemistry answers in isotopes as much as in molecules. Each furnace week peels the lightest atoms first, hydrogen and nitrogen escape with fractionation that enriches deuterium and heavy isotopologues over many seasons. Sodium and potassium, sputtered from surface and cloud tops, broaden into fat lines with non-Maxwellian wings because pickup ions sample velocity space unevenly. Nitriles polymerize into Tholin hazes that collapse as brown frosts when the world coasts back into dark. Peroxides and odd nitrogen rain into brines, where they oxidize sulfides and drive serpentinization that vents hydrogen back up, a closed, gravity-timed redox loop. If biology ever joins the conversation, it will inherit those clocks and chemistries, enzymes pre-arm for radiation bursts, membranes swap unsaturations to ride peroxide tides, and metabolisms hoard oxidants laid down at auroral caps, then spend them in the slow, dark months below. Deep inside, mineral physics conducts the score. As pressure and temperature sweep across phase boundaries on a monthly cadence, olivine flips polymorphs, clinopyroxenes exsolve, and water migrates between lattice sites and melt. Short, hard pulses near closest approach drive dehydration fronts upward. During the coast, rehydration creeps downward along grain boundaries. The alternation welds glassy veins that freeze in minutes, arrows pointing toward the instantaneous tidal axis. In ice, clathrates build and pores during the long winter, then collapse when pressure drops in fractures at the plunge, venting bouquets of methane crystals that sift downwind like volcanic lapilli. Even a dead world becomes a diarist. Microseisms at the body's normal modes ring on every pass, and their slow drift in frequency as the orbit fattens or thins is a seismogram of orbital evolution. Rings and rubble add their own punctuation. Pointing Robertson drag is not sun-driven here but furnace-driven. The anisotropic radiation bath at pericenter does the work, nibbling semi-major axes in bursts. Plasma drag contributes an impulse as the ring punches the bow shock. Between drives, self-gravity wakes and inelastic collisions cool the debris into narrow lanes, only for differential precession to twist them into spiral barcodes whose spacing records the local gravity gradient and the central quadrupole. A shepherd moon that clung on will sculpt scallops. If that moon is peeled during a hard season, optical depth steps down abruptly and stays low, a timestamp in geometry. Crowds make corridors. Near epicenter, mean motion resonances between otherwise invisible citizens can lock pericenter distances, freezing the dangerous angle while the plane nods. Secular resonances tied to the larger cluster trade eccentricity for inclination, sending some survivors onto high-latitude loops that seed the inner glow with polar dust. Occasionally a compact remnant dives through, a neutron star on an eccentric chute, a small black hole on a plunging pass, and flicks a traveler's ellipse over the red line. The aftermath is bright and diagnostic. A thin streamer phase wraps, self-intersects, and builds a broken hoop whose precession rate is a clean measure of the central spin. Charged grains drift into polar brushes that, when they skate across a backlit filament, carve knife-edged dips in a light curve that step with ring thickness and nod with frame dragging. From far outside the lamp city, the signs are subtle but stackable. Mid-infrared light curves that crest on schedule but creep in phase as pericenter advances, sub-millimeter bursts that cluster at predictable true anomalies where induction bites hardest, polarized flashes that arrive just before the heat peak when forward-scattered dust rings the globe, alkali lines broadened by pressure and spiced by sputtering during the hot week. Precision astrometry in the inner arcsecond of the galactic capital adds a statistical lever. Even if no single planet's tug is obvious, a population corrugates the orbits of faint tracers in a way that an interferometer with a long memory can peel out. In gravitational waves, only the tightest, heftiest survivors will murmur in millihertz bands, planet-scale extreme mass ratio whispers, but if the luminous arrondissement is generous, there will be more than one, and their chorused phasing will chart the deepest metric where photons and dust cannot go. The long fate of a captured sphere is a slow bargain with dissipation. Tides inside the world fatten the ellipse and lift pericenter. Weak hydrodynamic drag near the inner flow steals specific angular momentum. Resonant kicks from neighbors add stochasticity. Many paths round toward warm, dim embers threading inside the inner haze, where the globe sheds fine solids that catalyze molecule making in the glow. A minority ratchet upward in eccentricity until the corridor narrows to nothing and the world becomes ribbon, ring, and finally fog. Scale the central sovereign up and the safe lane for rock actually widens. The gradient softens, so an iron-heavy super-Earth can skim outside the photon ring and live. Scale down to a dwarf canton and survival demands almost impossible aim, so streams and newborn hoops become the norm. Spin and tilt never truly settle. Anisotropic re-radiation near pericenter, no sun required, acts like a YORP engine, whispering torque into uneven terrains and lopsided rings, chaotic tumbling toggles among resonant islands, 3:2 for a few centuries, 5:2 for a few more, then a sudden flip when the pedal angle lands wrong. Obliquity tides sip energy best at special tilts, and interiors with oceans or liquid cores lag the torque, ratcheting axis angles by fractions of a degree per thousand orbits. All of that is visible in principle because it changes the phasing of heat, the width of the crest, and the polarization angle of dust flashes. A map of those drifts over a handful of years is a poor man's interior probe, ice versus rock versus gas, dead core versus living dynamo, read across parsecs. Even the background turns into a tool. Pulsars grazing the inner burrow throw steady radio ticks. When the traveler swings between us and one of those clocks, the path length shifts by tens of microseconds from Shapiro delay in the central well and by nanoseconds more from the planet's own gravity, modulated at the orbital phase. Stack enough passes, and you isolate the small, periodic signature of a world that never transits anything and reflects almost no sunlight at all. If a bright filament snakes behind the globe at pericenter, microlensing by the planet briefly spikes the filament's brightness with a two-peaked, asymmetric blip whose separation encodes the Einstein radius and therefore the mass. Detect two such blips a year apart, creeping earlier by the apsidal advance, and you've weighed a nightbound object with geometry alone. Push imagination toward engineering and the constraints sharpen rather than blur. Power comes in tides and induction. Heat sinks are inexhaustible night. Communication loves the low-frequency bands where auroral physics already shouts. Infrastructure would cluster along stress shadows that go cool between furnace weeks. Drilling would follow seismic nodes that ring strongest at each pass. Agriculture, if chemistry earns the name, would be brine-based, redox-timed, and shielded under meters of ice or rock. Waste heat would crest too symmetrically unless managed. Haze clearing would fight photochemical production on a schedule written by orbit. Radio beacons would either avoid or lean into gyrofrequencies where the sky is loudest. Even without artifices, the natural cadence, thermal, polarimetric, spectroscopic, astrometric, gives us all the hooks we need. From a distant ridge where we label whole structures, the spiral dominion is a soft ember with a bright kernel. Drop to the level where a single captured sphere keeps time, and that kernel is a machine for writing memory into matter. Planets without dawns become clocks, rings turn into barcodes, dust wakes into polarizers, veins of glass into arrows that point toward pericenter long after the orbit has changed. The rule of the radiant municipality is austere but enabling. Part with the right energy in the right place, thread the corridor, and the city of suns will grant you a path that repeats. On each return you will be shaved by fields, cooked by photons, kneaded by tides, and lensed by geometry, and if you are stubborn, you will learn to live by it, leaving signals across the spectrum for anyone, anywhere in the island of lamps, who knows how to read a beat drawn by gravity. Astronomers often describe NGC 3414 as a cosmic chameleon, a galaxy that refuses to fit neatly into the tidy boxes of classification. Unlike the elegant spirals with their graceful arms or the smooth featureless ellipses, this system blends traits from multiple families, earning its reputation as a mutant of the galactic world. At first glance, it appears lenticular, a disc-like structure with a central bulge, yet its surrounding halo and tidal debris tell the story of violent encounters. Streams of faint stars arc outward like ghostly fingerprints of past mergers, wrapping the galaxy in a cloak of distortion that betrays a turbulent history. This stellar hybrid, sometimes called the peculiar lens, lies about 80 million light-years away in Leo. Its light, stretched across eons, carries encoded memories of collisions and assimilations that transformed it into the odd form we see today. Deep exposures reveal tidal shells and arcs, ripple-like structures that are the scars of swallowed companions. Such features suggest that the galaxy has feasted on smaller neighbors, pulling them apart with tidal gravity, weaving their stars into elongated filaments that glow faintly against the cosmic background. Unlike the majestic order of spiral arms, the body of this galactic anomaly is chaotic and asymmetric, its dust lanes warped and its stellar distribution uneven. Its nucleus is classified as a liner, a low-ionization nuclear emission line region, indicating the presence of a central black hole quietly accreting material. This weakly active core may not blaze like the quasars of more violent galaxies, but it hints at a restless heart still digesting matter from its disrupted environment. The result is a galaxy suspended between states, not entirely quiescent, not violently active, a liminal form in the evolutionary spectrum. The strange identity of this cosmic outlier makes it invaluable for science. It is a living fossil of galactic transformation, showing how mergers can twist orderly spirals into lenticular remnants, and how cannibalism reshapes structure and destiny. When telescopes peer deeper, they uncover knots of younger stars mingled with ancient populations, signs that bursts of star formation ignited during collisions before slowly fading into silence. Around it, filigrees of stellar streams whisper of interactions still unresolved, as if the galaxy carries its past as luminous trails etched into space. This distorted lens of stars, sometimes nicknamed the Misfit of Leo, lives within a modest galactic neighborhood but stands out as one of its strangest inhabitants. While many galaxies in the Leo constellation present the elegance of spirals or the quiet roundness of ellipticals, this hybrid is a patchwork of dynamical experiments. Observations with the Hubble Space Telescope and ground-based instruments have revealed its faint stellar streams and shells stretching outward like the fading echoes of a symphony. These loops are fossil records of accretion events, frozen ripples on a galactic pond stirred by gravitational intruders long ago. Kinematics show that the stars inside this cosmic renegade do not move with the smooth coherence seen in typical disks. Instead, their orbits are scrambled, some locked into rotating streams, others drifting chaotically, reflecting the scars of disruption. This complex internal structure suggests a violent reshaping not billions of years ago but in relatively recent cosmic times, leaving the galaxy still settling into equilibrium. The dark matter halo that envelopes it provides the invisible scaffolding for these distortions, binding together both native stars and the captured remnants of smaller systems. Astronomers consider this enigmatic lens a case study in how mergers alter galactic destiny. Spirals can be stripped of their arms, their gas reservoirs stirred into turbulence, their cores ignited with transient activity. In the aftermath, what remains is often a smooth lenticular body, but in this mutant form, the transition is unfinished, the process laid bare. By studying its structure, scientists glimpse the pathways by which orderly spirals are transformed into more spheroidal systems, linking the stages of cosmic evolution. Despite its chaotic past, the galaxy continues to harbor a central supermassive black hole. Spectra of its nucleus show signs of ionized gas and low-level accretion, like embers smoldering in the ashes of earlier conflagrations. This central engine may once have been more luminous, possibly triggered during one of its mergers, but now it glows faintly, a whisper rather than a roar. Around it, older stars dominate, painting the galaxy with the redder tones of ancient populations, though patches of bluer light betray younger stars born from merger-driven starbursts. In the realm of peculiar galaxies, this cosmic shapeshifter has earned a place alongside some of the strangest examples known to astronomy. Much like Centaurus A, with its warped dust lanes and enormous radio lobes, or Hoag's object with its near-perfect ring, the Leo mutant is a reminder that the universe does not follow simple templates. Galaxies are not static portraits, they are dynamic beings, constantly sculpted by the forces of gravity, time, and interaction. This hybrid system demonstrates that the neat categories of spiral, elliptical, and lenticular are only snapshots in a continuum of transformation. One of the most striking features of this oddball is the set of faint stellar shells that wrap around it like the layers of an onion. These shells are created when a smaller galaxy plunges into a larger one, its stars flung into radial orbits that pile up at certain distances, forming arcs of light. Over time, these shells dissolve into the background, but while they persist, they serve as archaeological clues to ancient cannibalism. In this way, the galaxy resembles Centaurus A or NGC 3923, other systems famous for their rippling stellar cocoons. Such structures not only reveal the violence of past encounters but also provide laboratories for testing simulations of galactic dynamics. The dark matter halo surrounding this cosmic anomaly plays a hidden but crucial role in its story. Though invisible, this halo acts as the silent architect of the galaxy's fate, dictating how mergers unfold and how tidal streams are preserved. When smaller galaxies are torn apart, their stars become luminous tracers of the underlying gravitational field. By mapping these faint arcs, astronomers gain indirect glimpses of the dark scaffolding that cannot be seen directly. In the case of this peculiar system, the survival of such structures suggests that its halo is both massive and extended, capable of catching and holding on to debris for billions of years. Comparisons to polar ring galaxies highlight another layer of its strangeness. In some images, the faint arcs of light encircling this object almost resemble the beginnings of a misaligned disk, hinting that one of its encounters may have involved the accretion of gas at an odd angle. Polar rings, such as those in NGC 4650A or NGC 2685, show how material can be captured and stabilized in perpendicular orbits, forming rare geometrical wonders. Though the Leo mutant does not possess such a grand ring, the chaotic trails of stars around it suggest a kinship with those more exotic specimens. The central bulge of this galaxy is another mystery. Photometric studies reveal that its brightness profile does not align cleanly with a simple disk or spheroid, but with a hybrid of both. This central light distribution, combined with its kinematically disturbed stars, confirms that it is not a settled system. Instead, it exists in a transitional state, a bridge between youthful spirals and the smoother lenticulars that dominate older galaxy clusters. Observing such an object is like catching a caterpillar mid-metamorphosis, its body reshaping before it hardens into a more permanent form. Its nucleus, classified as a liner, gives astronomers further intrigue. Liners are often associated with aging galaxies whose central black holes accrete at low levels. In this case, the faint emission lines suggest that gas stripped from companions has been funneled inward, feeding the black hole at a gentle pace. The result is a galaxy whose core whispers of activity but never screams like a quasar. Yet, even in its subdued state, the nucleus influences its surroundings, heating gas, ionizing clouds, and leaving subtle fingerprints across the spectrum. Taken together, the evidence paints this peculiar galaxy as a survivor, a system that has endured repeated collisions, absorbed smaller neighbors, and reshaped itself into something that defies easy classification. Its story is written across multiple layers: faint shells, twisted dust, disturbed orbits, and a restless nucleus. Each of these features is a sentence in a cosmic chronicle of change, reminding us that the grand narrative of the universe is one of continual transformation. Seen through deep exposures, the Leo renegade looks like a memory in the act of forming. Its main body is smooth and lens-like, yet the outskirts are stitched with gauzy arcs and folded ripples, the kind of low-surface brightness structures that only appear when a larger system swallows smaller ones and the stars from the victim stack up along shared turning points. Each arc is a kinematic breadcrumb. Follow enough of them and you can infer not only the mass distribution of the host but the timing of the encounter that made the ripple. Computer experiments that throw dwarf galaxies into more massive disks reproduce the same onion skin geometry, and the same slow fading as dynamical mixing erases sharp edges over a few orbital periods. From the center outward, this lenticular misfit refuses to behave like a settled disk. Long slit and integral field maps of starlight show that the velocity field twists as you move away from the nucleus, as if different generations of stars remember different rules. Some orbits are nearly circular, others plunging and elongated, and the misalignment between the photometric axis and the kinematic axis hints at a triaxial potential, a not quite round gravitational well shaped by past mergers. In places where faint dust threads cross the bulge, the absorption lanes tilt relative to the main body, a telltale of gas arriving from odd angles rather than condensing peacefully in the original plane. The shell-draped Enigma carries a nucleus whose spectrum fits the liner archetype, emission lines from low ionization species that advertise a central engine accreting modestly. That engine is almost certainly a supermassive black hole scaled to the galaxy's central velocity dispersion, a quiet heavyweight more ember than bonfire. Even at a subdued pace, such a core can stir its surroundings, ionizing residual gas, nudging pressure balances, and subtly regulating any leftover star formation that merger shocks once ignited. Star formation histories extracted from absorption features suggest a mosaic, an old, metal-rich population that dominates the luminosity budget, laced with pockets of intermediate-age stars likely born when infalling gas was shocked and compressed. Ultraviolet imaging of the tidal debris often reveals the last sparks of those episodes, blue pinpricks scattered along the streams like campfires in a desert after the festival has ended. The gas reservoir today is meager, typical for transformed disks. Whatever cold material remained after the skirmishes was either consumed in brief starbursts, heated, or expelled. As a laboratory for dynamics, this Leo outlier is unusually generous. The spacing of its shells encodes the gravitational potential, the thickness of each arc traces phase-mixing timescales, and the brightness contrast between adjacent ripples constrains the mass ratio of the encounter. Where the stellar streams curve, planetary nebulae and globular clusters can be used as test particles, measure their velocities and you sketch the invisible scaffolding of dark matter. The resulting portrait tends to favor a massive, extended halo, exactly the kind of structure that can catch and preserve tidal debris for gigayears rather than letting it vaporize into the background. The kinematically tangled waif does not live alone. It sits in a modest association where slow encounters are plausible, the sort of environment in which repeated minor mergers, rather than a single catastrophic smash-up, can gradually erase spiral architecture. In such neighborhoods, galaxies age not by isolation but by assimilation, trading angular momentum for random motion until the original disk forgets its symmetry. The current morphology, smooth core, warped dust, ghostly skirts, looks like a snapshot taken partway through that assimilation, a chrysalis rather than a final form. Compared with canonical peculiar systems, the tidal alchemist is more understated than a classic polar ring showpiece yet more unruly than a pristine S0. It shares with Centaurus A the language of shells and with NGC 2685 the suggestion that matter can arrive on misaligned orbits, but it translates those dialects into a quieter script. Where some galaxies advertise their strangeness with neon, this one writes in graphite and fog. That subtlety is an advantage. The fainter the structures, the more faithfully they remember the past, because they have not yet been stirred beyond recognition. On the theoretical side, the chimeric lens is a stress test for simulations that track both stars and gas. Reproducing its mixed kinematics demands more than a single head-on collision. You need a sequence where angular momenta don't line up, where gas is fed inward in bursts, and where feedback from the nucleus never quite detonates into a full-scale quasar phase. N-body plus hydrodynamic runs that sprinkle in minor satellites on inclined orbits yield the right combination of warped dust, counter-rotating patches, and shell spacing. They also predict a slowly rising central mass-to-light ratio as older, redder stars dominate, consistent with the galaxy's muted colors. Zoom in, and the accretion-sculpted remnant speaks in chemistry as well as motion. Metallicity gradients flatten wherever tidal stirring has mixed the disk, while localized bumps in alpha element ratios mark locations where short, intense starbursts once spiked the enrichment. Even the dust tells on itself. Its grain size distribution shifts after shocks, leaving fingerprints in the far infrared that observers use to time the last major disturbance. If the dust lanes look threadbare now, that is because turbulence long ago shredded the larger clouds and left behind finer, more homogeneously mixed debris. The misaligned relic is also a reminder of how black holes and bulges co-evolve outside the spotlight of luminous AGN. In a system like this, accretion proceeds in sips rather than gulps. Over long spans, those sips still matter. They keep the central engine warm enough to ionize gas and perhaps launch weak, thermally driven outflows that prevent the immediate recollapse of any cooled material. Such gentle maintenance, feedback in soft focus, can explain why the present-day star formation rate is low without invoking a dramatic blowout. Out in the fringe, the halo carries a second archive, the globular cluster system. Blue, metal-poor clusters often trace an ancient backbone assembled early, while red, metal-rich clusters shadow the bulge and any subsequent starbursts. Count them, map their orbits, and you can read which components were born in situ and which were adopted. In many transformed disks, the outer cluster system is kinematically hotter than the inner one, as if the outskirts remember the jostling hands of mergers more vividly than the core does. The same logic likely applies here, reinforcing the picture of a galaxy stitched from many smaller stories. For observers, the shell-ringed paradox is a challenge in contrast. Its most revealing features hover barely above the night sky's glow. Amateur telescopes under pristine conditions can tease out the brighter arcs, but it takes long integrations on large apertures, or the surgical sharpness of space telescopes, to chart the full lattice of debris. Each added hour of exposure is like brushing away another layer of dust on a fossil. Contours sharpen, new ripples emerge, and the past becomes less hypothetical. As a signpost for cosmic futures, the hybrid outcast offers a quiet prophecy. Given enough time and enough minor accretions, even well-ordered spirals can relax into smooth, gas-poor lenses. Our own Milky Way, destined to tangle with Andromeda, will not end up identical to this object, yet the broad arc of transformation, disks heated, orbits randomized, nuclei fed episodically, echoes the same theme. Galaxies are biographies written by gravity. This one just left more of its drafts in the margins. In the end, the Leo anomaly is compelling precisely because it is unfinished. Its shells have not yet dissolved into invisibility, its kinematics have not yet aligned into a single, forgetful equilibrium, and its core has not yet gone completely dark. It is a living time machine that lets astronomers watch metamorphosis mid-spell, a place where the tidy textbook sequence of spiral lenticular elliptical blurs into a richer grammar. To study it is to admit that the universe edits constantly, and that the most truthful portraits of galaxies are sketched while the paint is still wet. Push the exposure deeper and the misfit of Leo turns into a tidal palimpsest. What looks smooth at casual glance resolves into an embroidery of structures riding on different clocks, inner stars that complete an orbit in a few 100 million years, outer streams that need billions, and shells whose edges sharpen where those clocks momentarily synchronize. In simulations, this phase wrapping produces the same nested arcs seen around the lenticular chimera, with their spacing quietly encoding the mass profile of the host. Read them carefully and you extract a history, how radial the intruder's plunge was, how massive the encounter, how long ago the splashdown happened. Integral field spectroscopy paints the wayward lens as a kinematic jigsaw. Inside one effective radius the velocity field twists, and beyond it the dispersion swells where overlapping orbit families crowd together. It is the signature of a triaxial potential. The gravity well is neither perfectly round nor simply disk-like, and of stars inherited from multiple progenitors. Some patches even look like a kinematically decoupled core, a central enclave whose stars rotate on a misaligned axis. The fossil of gas that once streamed in along a tilted plane, formed stars, and froze its own memory into motion. In places, the ionized gas refuses to follow the stars at all, preferring orbits set by the last accretion event. That misalignment is dynamical graffiti left by merger geometry rather than calm, in-plane cooling. Across the spectrum the shell-draped enigma keeps yielding clues. In the ultraviolet, faint beads of recent star formation hang along debris where shocks briefly compressed gas. In the mid-infrared the dust glow is modest, suggesting the remaining cold reservoir is thin, typical for transformed disks whose gas was either consumed in merger-triggered bursts or heated and stirred beyond easy collapse. At 21 centimeters, extended neutral hydrogen is scarce or displaced, another hint that tides and ram pressure from the local medium have rearranged the pantry. X-ray images mostly show the pointiest light of old binaries with perhaps a whisper of soft diffuse gas, nothing like a blazing, cluster-scale atmosphere, consistent with a system evolving by slow, repeated nibbles rather than a single cataclysmic smash. Spectral fingerprints turn the tidal paradox into a population mosaic. Lick index measurements and full spectrum fits describe an old, metal-rich backbone with supersolar, alpha/Fe, near the center, evidence for brief, intense star formation long ago, overlaid by intermediate-age pockets in the outskirts where streams cross. Metallicity gradients are flatter than you'd expect for an untouched spiral, as if a cosmic spoon had stirred the pot. Where shocks once tore through clouds, alpha elements spike in tiny plateaus. Where dust lanes have thinned, the far IR slope hints at grain processing by turbulence and time. At the very heart, the peculiar lens hosts a restrained engine. Its nucleus wears the badge of a liner, low ionization lines that point to a supermassive black hole accreting in sips. That is enough to keep ambient gas warm, discourage wholesale cooling, and sustain low-level outflows, but not enough to ignite a quasar. Maintenance mode, not demolition. Over gigayears, such gentle feedback can explain why the present star formation rate is low without invoking a dramatic blowout. The center stays just energetic enough to prevent a full reset. The halo is the true archivist. Globular clusters orbit through the outskirts as bright, countable tracers. The blue, metal-poor population maps the ancient framework assembled early, while red, metal-rich clusters echo later, more dissipative episodes. Measure their velocities and you weigh the dark matter scaffolding that cradles the entire structure. Planetary nebulae offer a second set of beacons. Their narrow oxygen lines are easy to catch against the night, letting astronomers chart the velocity field far beyond where starlight alone is practical. Stitch those measurements together with Jeans or Schwarzschild models and a consistent picture emerges, an extended halo that is massive enough to keep tidal debris coherent for a long time, but not so deep that all signatures are erased quickly by violent relaxation. Environment sets the tempo for this oddling. It inhabits a small association where galaxy-galaxy speeds are modest, the perfect breeding ground for repeated minor mergers, harassment, and slow gas starvation. In such neighborhoods, disks fade not by loneliness but by assimilation. Interactions trade ordered rotation for random motion, thicken the stellar body, and exhaust or heat the gas that would otherwise build fresh arms. The result is precisely this half-remembered disk, a whirlless body with a smooth face and a haunted periphery. For observers, the tidal palimpsest demands patience and craft. Its most telling structures hover at surface brightnesses fainter than 28 to 29 mag arcsec superscript 2, where imperfect flat fielding, scattered light, and sky subtraction can forge false ghosts or erase true ones. Long integrations, careful dithers, and aggressive control of internal reflections are not optional but existential. Each additional hour of exposure peels back another layer, arcs that were guesses turn into curves you can trace, and streams you suspected become highways for kinematic probes. On the theoretical side, the chimeric S0 is a truth serum for simulations. It resists explanation by a single, head-on merger, reproducing the mixed kinematics, misaligned gas, and shell geometry usually requires a sequence of encounters with varied orbits and mass ratios. Hydrodynamic runs that dribble in satellites along inclined paths naturally yield warped dust, counter-rotating pockets, and a liner-like nucleus that never quite tips into a high accretion phase. They also predict a slow, inside-out rise in mass-to-light ratio as aging stars dominate, just what the muted colors and elevated central dispersions imply. Even timing the last big disturbance is possible if you take the cosmic seismology seriously. Shell edges sharpen where stars on radial orbits pile up at epicenter, the spacing between them scales with the orbital period in the host potential. Fit that spacing, fold in the observed dispersion, and you get a clock that reads, a few dynamical times ago. Not yesterday on cosmic scales, but not so ancient that phase mixing has dissolved the evidence. That intermediate age is precisely why the wayward lens is so instructive. We catch it in mid-metamorphosis rather than eulogizing a finished form. Projecting forward, the rippled relic's fate is quiet convergence. As the brightest streams dissolve into the background and any remaining gas trickles inward or drifts away, the body will settle into a smoother, more forgetful lenticular. The nucleus may dim further, the metallicity gradient may continue to flatten, and the kinematic twists may relax toward a single dominant axis. Decades from now in telescope time, but hundreds of millions of years on the galaxy's clock, the misfit of Leo will look less like a confession and more like a polished alibi. Yet for now, the tidal palimpsest keeps its marginalia intact. It reminds us that morphology is grammar, not law, that dark matter is the silent author whose plot is revealed by the orbits of faint tracers, that black holes can shepherd evolution with a nudge rather than a blast. Above all, it shows that galaxies are not categories but biographies. The peculiar lens is a chapter where the handwriting changes mid-page, where edits and crossings out are still visible, where the meaning is richest precisely because the story is unfinished. Push closer to the threshold of darkness and the Leo chimera reveals subtler signatures, isophotes that twist with radius, a quiet cue that the underlying mass is triaxial, and a faint skewness in the light profile where shells pass behind the main body and briefly brighten its outskirts. Photometric decompositions that try to force this rebel into tidy bulged disk molds inevitably leave structured residuals, the image processing equivalent of a raised eyebrow. Subtract a smooth model and the page margins fill with handwriting, arcs, spurs, and wisps, none of which belong to a settled, razor-thin disk. Even the central brightness slope resists a single textbook Circic curve, as though different epochs of assembly have stacked their own layers of starlight, each with a distinct memory for how steep or shallow a galaxy ought to be. In kinematic space, the chimeric lens behaves like a city built over older cities. Cold, nearly circular orbits course through parts of the inner body, but only a few hundred parsecs away the velocity ellipsoid fattens, and random motions dominate. The misalignment between the photometric major axis and the rotation axis is a smoking gun. The potential is not axisymmetric, and some stars are streaming along paths inherited from progenitors that approached on inclined or even polar tracks. Where ionized gas survives, it draws its own map, sometimes counter-rotating, sometimes nearly at rest, an honest cartographer of the last gas-rich accretion rather than a faithful follower of the stellar streets. Multi-wavelength views keep deepening the portrait. Far ultraviolet pinpricks mark the places where merger shocks briefly compacted gas into dense knots, now fading toward quiescence. In the near-infrared, the old, red backbone dominates, unveiling the true shape of the stellar mass without the cosmetic noise of short-lived blue stars. At longer infrared wavelengths, the dust continuum is soft and unassuming, more ember than flame, consistent with a pantry largely emptied by past starbursts or heated into a phase reluctant to collapse. Radio maps at 21 centimeters struggle to find a grand reservoir, Any neutral hydrogen that remains appears scant, rearranged, or exiled to the periphery by tides. Treat the misfit of Leo as a seismograph and the shell pattern becomes a timepiece. Stars launched onto radial orbits during a merger pile up at apocenter, their densities cresting into nested arcs whose spacing reflects the host's mass profile and the time since impact. Measure those intervals, fold them through dynamical models, and an era emerges, not so young that the debris is razor-sharp, not so old that the ripples have fully dissolved, an in-between age where phase wrapping is vivid and instructive. In that window, even small differences in shell curvature and thickness reveal whether the intruder arrived headlong or skirted in on a grazing pass. The hybrid's globular cluster system adds footnotes to the chronicle. Blue, metal-poor clusters roam far out, relics of the earliest scaffolding assembled when the universe was denser and rougher. Red, metal-rich siblings huddle closer to the bulge, echoing later, dissipative episodes when gas pooled and formed stars in surges. Their velocities, easy to sample with narrowband filters and efficient spectrographs, become tracer bullets for the dark matter halo. Stitch cluster and planetary nebula kinematics into genes or orbit superposition models and the invisible architecture takes shape, an extended halo that is deep enough to keep streams coherent for gigayears, yet not so violent as to erase their memory overnight. If the lens-shaped renegade once hosted a bar, hints of that past may linger in subtleties, boxy isophotes, faint X-shapes in the residual light, or small, sigma drops where bar-driven inflows cooled and formed stars with unusually ordered motions. Even without a surviving bar, the consequences of past non-axisymmetric structure remain, resonances that trapped orbits, inner rings that were half-built then shredded, and nuclear spirals that shepherded gas toward the black hole in fitful episodes. Each trace is a fossil of angular momentum being shuffled, the quiet work by which disks thicken and memory smears from rotation into dispersion. Chemistry plays historian. Abundance ratios that trend toward enhanced alpha elements near the core point to short, intense star formation timescales early on, while flatter metallicity gradients across the body betray thorough mixing by tides. In the debris, localized metallicity plateaus and irregular dust-to-starlight ratios mark places where the intruder's material still speaks in its own accent. Grain-size diagnostics in the far infrared suggest that shocks once shattered larger dust into finer fragments, leaving a smoother, more homogeneously mixed residue that radiates gently instead of blazing. At the center, the shell-draped Enigma runs on maintenance mode. A liner-like spectrum says the supermassive black hole is sipping, not gulping. Photoionization and weak, thermally driven breezes keep the surrounding gas just warm enough to resist collapse. This is feedback as a thermostat rather than a storm, precisely the kind of low-key regulation that can keep a galaxy's star formation rate pinned near zero without the spectacle of jets punching kiloparsec holes or quasar winds raising the pantry. Over long times, the integral of small accretion events still grows the black hole and polishes the cusp of the central light profile. Environment tunes the dance. The Leo outlier inhabits a mild traffic neighborhood where relative speeds are low enough for minor mergers and repeated flybys to matter. In such places, the path from spiral to lenticular doesn't require a single, catastrophic smash. Instead, a series of unspectacular encounters heats the disk, nibbles away at gas, and trades ordered rotation for randomness. Gas starvation from the group medium may do the rest, remove the fuel, and the dynamo of spiral arm regeneration stalls, leaving behind a smooth, anodyne face and a haunted periphery. For observers, the stitched lens is an exercise in discipline. Its telling structures live in a regime where sky subtraction errors masquerade as features, where reflections inside the optics write bright lies, and where flat field imperfections sculpt fake rivers of light. Success demands long integrations, clever dithers, and amongst patience in processing. But the payoff is exquisite, curves of debris you can follow like rivers across the frame, streamers that thread behind the main body and reappear, slightly dimmer, like a whispered refrain, shell edges that sharpen as the signal builds, turning conjecture into cartography. Numerical experiments treat the aberrant S0 as a benchmark. Runs that sprinkle in a sequence of satellites on misaligned orbits reproduce the collage of traits: warped dust, gas, star misalignment, shell spacing, and a nucleus that never quite climbs into a quasar phase. Add in a moderately triaxial halo and the isophote twists fall out naturally. Let the ensemble evolve for a few dynamical times and the inner velocity field begins to unwind toward a single dominant axis, while the outer debris fades into the textbook smoothness of a classic lenticular. The very future, the ripple-marked remnant, is quietly approaching. Project the story forward and the tidal palimpsest trends toward serenity. Streams diffuse into the background, metallicity gradients flatten further, and any lingering pockets of cold gas either trickle inward to be warmed by the nucleus or evaporate into the group medium. The black hole will keep its ember-bright diet, the central dispersion profile may relax, and the photometric residuals will simplify as the most delicate filigree crosses below detectability. The misaligned relic will look less like a confession of past violence and more like a polished ellipsis, an object that hints at history without displaying the footnotes. Yet today, the chimeric S0 remains a classroom with the lights on. It teaches that morphology is a verb, not a noun, that dark matter's handwriting is legible in the orbits of the faintest tracers, that black holes can supervise evolution with nudges rather than edicts, that the universe edits its drafts in public if you take long enough exposures to watch. The cosmic chameleon is not an exception to the rules, it is the rule revealed at an awkward, invaluable midpoint, when the paint is still wet and the brushstrokes of gravity are easiest to read. Push the modeling further and the Leonine shapeshifter becomes a case study in orbital archaeology. Build a library of thousands of possible stellar paths, short-axis tubes, long-axis tubes, box orbits, and let an orbit superposition code assign weights until the composite light, velocity, and dispersion fields match the data. The best-fit solutions rarely choose a single family, they favor a mixed constitution with moderate anisotropy, beta rising with radius as random motions take over from rotation. That gradient is exactly what you expect when a disk has been heated by multiple minor encounters rather than pulverized by one spectacular crash. Treat the lenticular oddball as a laboratory for isophotal diagnostics and its contours start to speak. The A4 parameter toggles between slightly boxy and slightly disky with radius, a fingerprint of embedded substructures, maybe a faded bar remnant inside and shell light contaminating the outskirts. Ellipticity doesn't simply climb and plateau, it meanders, hinting at a triaxial figure whose intrinsic axes are unequal and misaligned with the line of sight. Even the position angle twists by a few degrees, a quiet confession that the mass distribution is not a classical, coaxial bulge plus razor-thin disk but an asymmetric relic still remembering its last ingestion. In population space, the merger mosaic looks like a quilt stitched from different epochs. Single stellar population fits label the core as old and alpha-enhanced, rapid early enrichment, while the intermediate radii host stars with ages of a few gigayears, plausibly sparked when misaligned gas flows shocked and cooled during accretion. H-beta absorption strengthens gently outside the bulge, MGB, and fade drift in step with a flattened metallicity gradient, and the resulting maps resemble the aftermath of mixing by tides instead of the crisp gradients of an untouched spiral. Where debris arcs cross the main body, tiny plateaus in alpha/Phi, red like notes left by the intruder's chemistry. The nonconformist of Leo is dim in cold gas, but not mute. Any lingering neutral hydrogen prefers the outskirts, where tidal forces shepherded it into ragged filaments. CO searches find only wisps of molecular gas, consistent with a pantry emptied by earlier starbursts or warmed above the threshold for collapse. The mid-infrared continuum is soft and spare, more indicative of processed dust grains than lavish reservoirs, while far-infrared slopes betray grains that have been shock-shredded into smaller sizes, a memory of turbulence now long faded. Kinematically, the composite relic hints at a small, misaligned core that rotates faster than its surroundings, a kinematically decoupled component that could have formed when a last trickle of gas settled along a tilted plane and formed stars. Around that enclave, the velocity dispersion rises rather than falls, evidence that orbital families interweave and that the gravitational potential is not simply the sum of a spheroid and a cold disk. Ionized gas refuses to cooperate with the stars, sketching its own rotation axis set by the most recent accretion geometry, a stubborn cartographer ignoring the older street grid. The halo keeps the ledger. Blue, metal-poor globular clusters range wide, tracing the oldest skeleton. Red, metal-rich clusters cling nearer the center, echoing later, dissipative episodes. Planetary nebulae pepper the outskirts with monochrome beacons, their O3 lines bright enough to clock velocities far beyond the effective radius. Feed both tracer sets into genes analyses or orbit libraries and the dark scaffolding emerges, an extended, moderately concentrated halo that explains why shells persist for gigayears instead of dissolving in a handful of orbits. As an environmental product, the hybrid lens fits the script of group preprocessing. In slow neighborhoods where relative speeds are a few hundred kilometers per second rather than 1,000, encounters last longer and angular momenta don't average out. Disks are heated by a series of glancing blows, gas is siphoned or stirred, and arm-regenerating density waves run out of fuel. The endgame is a smooth, gas-poor body with low specific star formation and a history written faintly in the periphery, a description that matches the Leo Maverick almost too well. The central engine of the tidal scrapbook works on a thermostat. Liner-like emission lines say the black hole is accreting in a radiatively inefficient mode, adding heat without fireworks. That gentle maintenance keeps the immediate surroundings warm enough to resist wholesale collapse, preventing the reignition of a bright disk while avoiding the collateral damage of quasar-scale outflows. Over long spans, this slow diet still grows the black hole and gradually steepens the central light profile, but the growth is measured in decimal places, not exponents. For observers, the merger palimpsest is a masterclass in low surface brightness discipline. Faint arcs near 29 mag arcsec superscript 2 demand meticulous sky flats, careful baffling to suppress internal reflections, and dithering strategies that smear detector artifacts into insignificance. Stacked integrations transform suspicion into geometry, a thread that seemed illusory becomes a continuous curve, a suspected spur connects to a larger loop, a ripple hidden by scattered light stands up when the background is tamed. Narrowband filters tune to O3, and H-alpha turn planetary nebulae and ionized knots into crisp targets for multi-object spectroscopy, extending the kinematic map to radii where starlight alone would fail. Numerical experiments give the S0 renegade a plausible biography. Start with a spiral of moderate mass. Feed it 2 or 3 satellites over a few gigayears, mass ratios of 110 to 120, on inclined orbits. Allow a weak bar to form and fade as dynamical friction and gas loss thicken the disk. Introduce a final, slightly more radial accretion that seeds shells and delivers a modest dose of gas on a misaligned plane. Let the central black hole sip rather than gorge. Evolve for several dynamical times. The outcome, warped dust, gas-star misalignment, triaxial isophotes, nested shells, low specific star formation, and a liner nucleus, resembles the Leonine anomaly with striking fidelity. The oddball's future trends toward amnesia. As streams diffuse and the phase-wrapped shells smear into invisibility, the photometric residuals will quiet, the position angle twists will relax, and the velocity field will drift toward a single dominant axis. Globular cluster kinematics will continue to anchor the mass profile, but the most delicate filigree will slip below detectability, leaving behind a textbook S0 whose violent adolescence is legible only to extremely deep exposures. If an occasional dwarf still strays too close, its stars will be recruited into the outskirts without disturbing the calm, more footnotes than new chapters. Yet, even as it settles, the kinematic patchwork remains a touchstone for theories that try to link black hole growth, gas exhaustion, and morphological transformation. It demonstrates that galaxy metamorphosis need not rely on grand catastrophes. A doctrine of small, well-placed nudges can sculpt structure just as effectively. It shows that dark matter's shape is not an academic curiosity but a practical influence, governing how debris wraps and how long memories persist. And it reminds us that classification is only shorthand. The peculiar S0 is not an exception to tidy rules so much as evidence that the rules are averages over messy, individual lives. Push the analysis one step outward and the outskirts begin to converse with the cosmic web. Faint, linear wisps that align with larger-scale structure hint at anisotropic infall, preferred directions along which satellites arrived and gas once streamed. Align those features with the orientation of neighboring galaxies and you often find coherence on scales far beyond a single halo, a whisper that the merger history of this quiet-looking object is entangled with the scaffolding of the universe itself. In the end, the leonine shapeshifter earns its nicknames because it refuses to be a single thing. It is a lens without perfect symmetry, a disk without spirals, a spheroid with memory. It is a book whose margins are crowded with edits, shells tracing epicenters, dust lanes tilted against the grain, clusters and nebulae marking orbits through an unseen potential. To read it well is to slow down and let faint light do the talking, to accept that the universe writes its biographies in drafts, and that the most instructive pages are the ones where the revisions are still visible. Treat the Leo chameleon as a stability experiment and the physics becomes concrete. A beefed-up bulge raises the epicyclic frequency and boosts the tumor Q of whatever cold gas remains, a recipe for morphological quenching. Even without a dramatic purge by jets or winds, the thickened central mass makes it harder for spiral instabilities to grow. The result is the visual calm of a lenticular face masking a history of turbulence. The disk has not forgotten how to form stars, it has simply been stabilized into silence. If the mutant lens ever hosted a grand bar, its afterimage likely lingers in kinematics rather than in obvious light. Subtle box/peanut hints in isophote residuals and small sigma drops can betray past bar-driven inflows that ferried gas inward on X1 orbits, then spun up a compact, younger component on a tilted plane. When those inflows ebbed and the gas supply thinned, the bar faded, leaving a kinematically decoupled enclave whose rotation axis does not fully agree with the outer body. The shell-embroidered remnant is also an archive of scattering events. Each minor merger trades a little ordered rotation for random motion, pushing the anisotropy upward with radius. Orbit libraries that fit the velocity field tend to blend short-axis tubes with box orbits in the outskirts, exactly what you'd expect if satellites arrived on varied, misaligned paths. That mix naturally explains why the photometric position angle twists gently, why ellipticity meanders with radius, and why the ionized gas draws a map of its own rather than following the stellar streets. Chemistry adds a quiet second voice. Alpha enhancement near the core marks fast, early enrichment. Flatter metallicity gradients across the body speak to tidal stirring that smeared out the sharp contrasts of a pristine spiral. Along debris lanes, localized plateaus in alpha/Fe, red-like accents preserved from the swallowed companion, while far-infrared slopes suggest grain populations processed by shocks, larger dust shattered into finer fragments that now radiate like embers rather than torches. The tidal scrapbook's distance can be cross-checked by multiple rulers. Surface brightness fluctuations in the red/near IR capitalize on the graininess of unresolved stars, delivering a smooth, geometric-like gauge for quiescent systems such as this. Planetary nebula luminosity functions offer a second yardstick, their bright end cutoff acting as a standard candle while simultaneously extending kinematics well beyond the effective radius. When those methods converge, they lock down the scale on which streams arc and shells repeat. On radio and sub-millimeter dials the hybrid S0 speaks softly. Neutral hydrogen is scarce or shunted to ragged filaments, molecular gas, when detected, arrives as wisps and knots. That scarcity is consistent with a pantry emptied in merger-triggered bursts or warmed into a phase reluctant to collapse. Without a cool reservoir, the disk cannot easily regenerate arms, even if densities rise locally. The raised Q and gentle AGN thermostat nudge the gas back from the brink. The shell-draped S0 is a superb dark matter seismograph. The curvature and spacing of its ripples measure the potential. Globular clusters and planetary nebulae fly as bright tracer bullets through the invisible well. Fit their velocities with genes or orbit superposition models and the halo emerges as extended and moderately concentrated, deep enough to cradle debris for gigayears, not so violent as to erase it in a handful of orbits. That balance is precisely why the galaxy is such a pedagogical sweet spot. Memory persists without overwhelming the present. In the soft X-ray, the chimeric lens is modest. Point sources from old binaries punctuate a faint glow rather than bathing the system in cluster-like gas. That quiet is another environmental clue. The object lives in a low to moderate density neighborhood where slow encounters, mild harassment, and starvation by the group medium can reshape disks without the brutal ram pressure of rich clusters. Transformation here is cumulative, not catastrophic. Deep imaging turns technique into truth. Features at 28 to 30 mag arcsec superscript 2 live where sky subtraction, ghosts, and flat field errors love to lie. Long integrations, careful baffling, aggressive dithers, and meticulous background control are less nice to have than mission critical. Stack enough clean frames and conjecture hardens into cartography, a spur becomes a loop, a suspected break connects into a full shell, and a filament you only guessed at reveals a continuous path behind the main body and back out again. The Leonine outlier also lets theory meet data at human timescales. Cosmological zoom-ins that sprinkle in 110 to 120 satellites on inclined orbits naturally reproduce the same collage: warped dust, star-gas misalignment, nested shells, a kinematically quirky core, and a nucleus that idles in a radiatively inefficient state. Let the simulation run for a few dynamical times and you watch the same slow unwinding predicted for the real system. Twists relax, dispersion dominates the outer body, and the faintest filigree fades beneath detectability. Even the star clusters carry a chorus line of history. Color bimodal globular systems, blue metal poor roamers and red metal rich homebodies, encode the timeline of accretion versus in situ growth. Their spatial distributions and anisotropies map which parts of the halo assembled early and which were quilted on later. In many transformed disks, the outer, bluer population is kinematically hotter, remembering the jostle of mergers more vividly than the red inner clan, a pattern the Leo misfit is primed to echo. As a laboratory for black hole scaling relations, the peculiar lenticular is a useful restraint. A linear nucleus implies low Eddington ratios, but the central velocity dispersion still ties the black hole mass to the bulge through familiar correlations. Slow, steady feeding, more sips than gulps, accumulates over gigayears, subtly sharpening the cusp of the light profile without ever lighting the beacon of a quasar. Project the future of the stellar chimera and the arc is toward amnesia with trace elements. Shells will phase mix into a diffuse haze, metallicity gradients will flatten by small, persistent degrees, and the position angle twists will relax as orbital families settle into a dominant axis. Any stray dwarf captured along the way will be stitched onto the periphery like a new footnote, but the main text will read ever more like a classical S0, smooth, gas-poor, and politely forgetful. Yet the present is the most instructive frame. The asymmetric lentil is caught in the middle of an edit, its margins still full of corrections. It demonstrates how bars can form and fade, how minor mergers can heat and thicken, how dark matter sculpts memory, and how black holes can supervise the transition with a thermostat rather than a flamethrower. It shows that galaxies are verbs disguised as nouns, processes we insist on naming as objects. Stand back and the lesson is simple and generous. The hybrid S0 is not a violation of classification, it is the reason classification must be flexible. Its shells are clock faces, its clusters are signposts, its dust is a diary, and its nucleus is a dim pilot light keeping the system warm enough to stay quiescent. The more patiently we look, the more plainly it says, evolution is continuous, memory is faint but measurable, and the universe does its finest teaching in the low contrast edges where stories are easiest to miss. Push beyond the familiar diagnostics and the Leo Maverick turns into a proving ground for nearly every tool in extragalactic astronomy. Velocity fields from integral field units can be decomposed into harmonic terms, and the higher-order coefficients, the h3 and h4 of the line-of-sight velocity distribution, betray non-Gaussian wings where overlapping orbit families coexist. In the inner kiloparsec of this off-axis lens, an anti-correlation between h3 and v/sigma would point to a discier subcomponent embedded in a rounder body, while positive h4 pockets hint at radially biased orbits delivered by past accretion. Those subtle shapes in the spectra are time capsules. You don't need to see the intruder anymore to prove it was there. The asymmetric lentil also stress tests angular momentum metrics. The luminosity-weighted spin parameter lambda_r, measured across effective radii, can place the system among fast or slow rotators, but the classification hides nuance. A chimeric S0 can present as a borderline fast rotator inside one r_e while its outskirts are dispersion-dominated, a sign that heating by minor mergers thickened the disk and diluted coherent motion. Radial profiles of lambda_r that rise, stall, and then decline are entirely natural for a body knitted from misaligned pieces. They are the kinematic handwriting of an object that was spun up, stirred, and then steadied. Look at the distorted lens through the lens of scaling relations and more clues emerge. On the mass-size plane, it sits where quenched disks gather. On the fundamental plane, it follows the tight relation of early types but with a mass-to-light ratio that quietly increases toward the center, as older, metal-rich stars dominate the light and dark matter contributes modestly within r_e. Compare its faded Tully-Fisher residuals to spirals and you'll find the offset expected for a disk that lost gas and luminosity while keeping much of its rotation until heating and misalignment began to take over. Where the shell-sheathed relic meets the interstellar medium, the physics is small-scale and decisive. The remaining gas feels an elevated shear and epicyclic frequency. The tumor Q passes the stability threshold. Turbulence and low-level AGN heating maintain pressures that oppose collapse. Magnetic support and a dearth of cold molecular reservoirs finish the job. Star formation doesn't stop because the galaxy forgot how. It stops because too many gatekeepers say, not now. If the post-spiral revenant ever flirted with prolate or minor axis rotation, that oddity would likely hide at larger radii where debris orbits along the long axis of a triaxial halo. Long slit cuts aligned with different position angles can catch such behavior, weak rotation where you expect none, or none where you expect some. Couple that with isophote twists and you have a triangulation of shape, evidence that the potential itself is skewed, not merely the luminous skin. The globular cluster chorus adds a statistical backbone. Blue clusters, older and poorer in metals, roam in wider, hotter distributions and remember the assembly of the earliest scaffold. Red clusters, richer and more centrally focused, echo later dissipative events. Their color histograms are often bimodal, but their kinematics can be trimodal when you add tidal debris to the mix. Map their velocities with multi-object spectroscopy and fold in planetary nebulae to extend reach, then feed both into action space models that separate components by orbital character. The outcome is not just a mass profile but a family tree of orbits, who was born here, who immigrated, and who still travels the long way around. Deep imaging of the Leo stray is a technical art. Low surface brightness structures live where systematics multiply, sky gradients masquerade as streams, scattered light paints false halos, and flat field imperfections turn into phantom rivers. The cure is redundancy and rigor, rotating the field, changing roll angles, building night sky flats, modeling pupil ghosts, and validating with independent instruments. When the residuals shrink, the genuine filigree stands up, loops that close, fans that feather outward, spurs that reappear behind the body with just the right dimming. Each successively deeper exposure is like an extra page of margin notes becoming legible. For the anomalous S0, future facilities sharpen every angle. A wide-field survey such as Rubin will catch ultra-faint plumes and satellite knots, timing the last major disturbance more precisely through shell spacing statistics. Euclid and Roman will deliver homogeneous shape and color maps to R_E scales that allow robust stellar population gradients and weak lensing context. JWST can isolate thermally pulsing AGB stars in the nearest streams to pin down intermediate age bursts, while ALMA and, later, the INGVLA can decide whether the molecular pantry is truly bare or simply diffuse and elusive. SKA Pathfinder HI mapping will test for exiled atomic gas beyond the optical edge, the ghost of a disk that once was. On the theory side, the galactic chimera is a classroom for distribution function thinking. Orbit libraries and made-to-measure models can be phrased in action, angle space, letting you tag debris by its conserved quantities and follow how phase wrapping paints shells. A sequence of 110 to 120 satellites on inclined orbits naturally yields the observed recipe: kinematic misalignment, triaxial light, shell nesting, weakly active nucleus, and a spin profile that rises and then softens. Introduce a modestly cusped dark halo and the persistence of streams over gigayears follows. Flatten the cusp and the debris geometry shifts in ways you can check against the data. Chemistry keeps offering ground truth. The core of the peculiar lens tends toward alpha enhancement and supersolar metallicity, a fingerprint of short formation timescales and efficient enrichment early on. The outskirts exhibit flatter gradients, tidal stirring as the cosmic spoon, and localized plateaus where the intruder stars still speak their native dialect. Dust SEDs imply grain processing by shocks, favoring smaller particles that radiate gently. Even the ionized gas line ratios argue for a soft photoionizing field with contributions from old hot stars and a low Eddington nucleus, maintenance mode, not fireworks. As an environmental story, the hybrid lens reads like group preprocessing writ small. Without the brutal ram pressure of a rich cluster, transformation is cumulative, gentle harassment, repeated flybys, gas strangulation, and a slow trade of rotation for dispersion. The end product looks quiet and unremarkable until you turn the contrast way down, then the margins bloom with memory. It is precisely this balance, present-day calm with archival turbulence, that makes the object such an efficient teacher. Project the shell-embroidered remnant forward and the narrative trends toward serenity. Streams fade into the background, the lambda_r profile smooths, metallicity gradients relax a little more, and the nucleus keeps its pilot light on. A wandering dwarf may add a new footnote, but no fresh chapter is likely unless a gas-rich companion arrives on a finely tuned orbit. Absent that, the orphan disk will crystallize into a textbook lenticular, its past legible only to those who know how to read the faintest glyphs in the sky. Stand back and the message of the Leo anomaly is almost embarrassingly clear. Galaxies are not categories, they are verbs. The misfit of Leo, the shell-draped enigma, the tidal palimpsest, the leonine shapeshifter, whatever nickname you give it, exists to show that structure is a consequence of history, that dark matter writes its plot in the paths of faint tracers, that black holes can govern with a thermostat rather than a blowtorch, and that the finest astrophysics often hides a hair's breadth above the noise. Push into the outskirts where starlight thins and the Leo outlier turns into a ledger written at the edge of detectability. There the surface brightness falls below the comfort zone of ordinary imaging, yet the geometry grows clearer, shells that pinch toward the minor axis, streamers that arc and briefly vanish behind the main body only to reappear with the right amount of dimming, fans that feather outward where phase-wrapped orbits crest at apicenter. Each curve is a constraint on the gravitational potential, each break in slope is a timestamp on the last encounter. Treat those contours as equations and the mass profile begins to solve itself. Closer in, the stellar kinematics of the cosmic chameleon describe a layered city. Cold, nearly circular orbits trace a faint inner disklet, a few hundred parsecs beyond, dispersion swells and the velocity ellipsoid fattens, announcing the transition to a hotter, merger-heated structure. The anticorrelation of H3 with V/sigma in the inner kiloparsec suggests a disky subcomponent embedded in a rounder host, while patches of positive H4 betray radially biased orbits, smoking guns for accreted stars that dive and linger on stretched paths before turning back. None of this requires a showy collision. A sequence of inclined minor mergers paints the same kinematic quilt with fewer theatrics and more persistence. The shell-wreathed S0 tells its chemical story with quiet emphasis. Near the core, alpha enhancement sits above solar, implying rapid early star formation that ended before Type Ia supernovae could dilute the signature. Intermediate radii host stars of a few gigayears, plausibly born when misaligned gas flows compressed during flybys and settled into short-lived rings. Farther out, metallicity gradients flatten as if stirred with a cosmic spoon, localized plateaus in alpha/Phi, along debris lanes read like accents from the swallowed companion, preserved because phase mixing has not yet erased their dialect. Dust, too, has a memory. The infrared spectral energy distribution leans toward processed grains, smaller, shock-shredded particles that glow as embers rather than blazing torches. The paucity of PAH features and the softness of the mid-IR continuum match a pantry that was once stocked, raided by bursty star formation, and then warmed into reluctance. Without a robust molecular reservoir, the asymmetric lentil is easy for tumor stability to police. Raised epicyclic frequencies and mild AGN heating keep Q above the threshold, so the disk remembers how to form stars but declines the invitation. Gas refuses to read the old street map. Where ionized filaments survive, they sketch a rotation axis misaligned with the stars, a cartographer loyal to the last accretion rather than to the ancient plan. In places the gas nearly counter-rotates, a dynamical confession that it arrived on a tilted plane, lost angular momentum to shocks, formed a sprinkling of stars, and then thinned into transparency. Such misalignment is not decorative, it is a chronicle of angular momentum exchange, a record of how a spiral's orderly traffic becomes the polite congestion of a lenticular. The tidal palimpsest is generous to dynamicists. Fit planetary nebulae velocities in the halo and they extend the rotation and dispersion profile well beyond where integrated starlight can compete with the sky. Fold those tracers together with globular cluster kinematics, blue, metal-poor roamers wide and hot, red, metal-rich homebodies tighter and cooler, and an extended dark halo emerges, moderately concentrated and mildly triaxial. That shape naturally explains the isophote twist with radius and the gentle meander of ellipticity, while giving streams a cradle deep enough to keep them coherent for gigayears. As a citizen of a low-velocity group, the leonine oddball illustrates preprocessing in action. Relative speeds are small enough that flybys last longer, torque each other more effectively, and exchange gas without tearing disks completely apart. Harassment heats the stellar body, tides siphon or stir the gas, and the supply lines for fresh cold material thin. The result is a quiescent face with haunted margins, a system that looks settled at first glance but reads like an archive once the contrast is turned down. Distance, scale, and calibration conspire in its favor. Surface brightness fluctuations in the near IR place the shell-embroidered remnant at a distance where 1 arcsecond maps cleanly to a few hundred parsecs, fine enough to resolve kinematic twists, broad enough to trace debris loops across wide fields. Planetary nebula luminosity functions cross-check that latter and, as a bonus, carry kinematics into the realm where globular clusters roam. With those rulers set, the timing of the last significant encounter is not guesswork but geometry, shell spacing ties to orbital periods, and the observed dispersion clocks how many wraps have passed. If the hybrid relic ever carried a strong bar, its fingerprint lingers in subtler statistics. Boxy isophotes in the inner light, faint X-shaped residuals after subtracting smooth models, or a modest sigma drop where cooler, bar-fed stars settled, each would be a fossil of non-axisymmetric structure that once funneled gas inward. Bars fade when gas runs out and disks thicken, but the resonances they imprint can trap orbits long after the visible scaffold dissolves. Such memory explains why some orbits remain unusually ordered inside while the outskirts prefer a more democratic mixture. Future tools will turn this misfit into a reference atlas. Wide-field surveys will catch ultra-faint plumes and satellite knots, letting shell spacing statistics time the last splash with better precision. Space-based imaging will carve crisp population gradients to the effective radius and beyond, isolating intermediate-age tracers that pin down when each ring of the mosaic was laid. Radio arrays will decide whether neutral hydrogen has been exiled to the periphery or truly bled away, and millimeter interferometers will test whether the molecular pantry is merely diffuse and elusive or genuinely bare. Simulations already rhyme with the observed collage. Cosmological zoom-ins that sprinkle in 110 to 120 satellites on varied, inclined paths yield triaxial light, lambda_r profiles that rise and soften, embedded disky cores, and a nucleus that idles in a radiatively inefficient mode, maintenance rather than fireworks. Add a mildly cusped halo and tidal streams persist on human observing timescales, flatten the cusp and the debris geometry shifts in ways the data can arbitrate. In this sense the Leo stray is not just a curiosity, it is a calibration target for the grammar by which gravity writes. Project the narrative forward and serenity is the asymptote. The faintest filigree will fade below detectability, position angle twists will relax as orbital families blend, metallicity gradients will smooth a little more, and the central engine will keep its pilot light on. A wandering dwarf may add a marginal note to the outskirts, but no new chapter seems likely unless a gas-rich interloper arrives on a precisely mischievous orbit. Absent that, the tidal scrapbook will mature into the textbook S0 that its face already suggests. For now, the stellar chimera remains a masterclass in how to read faint light. Its shells are clocks, its clusters are compasses, its gas is a contrarian historian, and its nucleus is a thermostat. The lesson is consistent and candid, structure is biography, dark matter is the invisible author, feedback can govern with whispers, and the best astrophysics happens just above the noise, where patience turns ambiguity into evidence and an unassuming lentil confesses its turbulent youth in lines so faint you must learn a new alphabet to see them. On the southern edge of the sky, a distorted barred spiral in Volans bends its two unequal arms like a thrown harpoon. Observers know it by many labels: Meat Hook Galaxy, the twin number 2442/2443, the Volans Hook, but all point to the same intermediate spiral whose bar and mismatched arms give the system its striking, hook-like silhouette at roughly 50 million light-years and on the order of 75,000 light-years across. The split designation traces back to 19th-century cataloging quirks. Early observers logged what looked like two nebulae, which later resolved into a single lopsided disk, hence the paired entries and the enduring habit of calling one arm NGC 2442, and the other NGC 2443. In this Volans oddity, the sharper, brighter arm is lined with H2 regions and threaded by a heavy dust lane, while the opposite arm kinks and fades, signatures of a recent gravitational run-in. Kinematic maps reveal non-circular motions and a briskly rotating nucleus, the dynamical fingerprints of tides that have shoved gas into shocks along the dominant arm and redistributed star formation without destroying the disk. AR-14 evidence for that encounter lingers beyond the starlight, a starless cloud of neutral hydrogen, HIPAS J0731-69, hangs nearby like a shed plume, likely torn from the galaxy during the flyby of a moderately massive companion. The hook's brightest knots are newborn clusters blazing blue against ochre dust, but its history is also written in stellar endings. A low-luminosity Type II event in 1999, SN 1999-GA, went off along one of the compact inner arms and was later revisited to study the aftermath. It marked a core collapse death somewhere in the galaxy's patchwork of recent star formation. In March 2015 another flash appeared, this time a normal Type Ia, SN 2015F, from a white dwarf pushed over the thermonuclear brink in a binary. Unusually early monitoring caught its rise and helped pin down the timing of first light, turning this lopsided spiral into a laboratory for supernova physics. Despite the drama, crooked arms, streaming gas, rippled velocities, the Volans Hook remains a disk galaxy that still roughly follows the Tully-Fisher relation, a reminder that tidal harassment can bruise a spiral without breaking it. Dynamical models suggest relaxation on 100 million year timescales and the prospect of another passage, perhaps an eventual merger, in the longer future, an evolution written in tides rather than in tranquility. All of this has been traced since John Herschel first swept it up from Cape Town in 1834, when the southern skies were being charted with new care. Today's images, Hubble's close-ups of the compact arm and core, wide-field views showing the extended hook, radio maps revealing the ghostly HI plume, let the meat hook, the harpoon, the volant spiral were its many names honestly, a single system, asymmetry incarnate, caught mid-gesture by gravity and still telling its story in light, dust, and motion. The meat hook galaxy is a study in asymmetry that still obeys the quiet mathematics of disks. Along the brighter, tightened arm, dust lanes sit just upstream of luminous H2 knots, an offset that betrays shock fronts where gas first compresses, then lights up as clusters ignite a few million years later. Farther out, the beads on a string rhythm appears, clumps spaced by the tug-of-war between self-gravity, shear, and feedback, a natural meter for star-forming spirals. Across the bar, gas experiences negative torques and drifts inward until resonances pile it up into a compact oval. There, cloud collisions become frequent and the interstellar medium jumps phases, molecular where the pressure is high, atomic where feedback has raked it thin. The hooked spiral looks chaotic in photographs, but the flows are legible to anyone who reads bars and resonances, dust for the shocks, H-alpha for the newborns, mid-infrared for the warmed grains, radio for the cold reservoirs that keep tomorrow's stars in escrow. The Harpoon galaxy carries scars of a past encounter that never quite broke its disk. One side shows compression and curvature, the other, stretch and dilution. Tidal forces did not randomize the orbits so much as redistribute them. Kinematic fields map this history cleanly, non-circular streaming along the leading edges, a twist in the velocity major axis, and subtle offsets between stellar and gaseous isophotons. None of it erases disk memory. The rotation curve still climbs and then plateaus against a dark matter halo, and the system's integrated luminosity and line width remain close to what the Tully-Fisher relation would predict for a spiral of this mass. The Volan's hook is a reminder that galaxies can be both perturbed and predictable. In ultraviolet, the lopsided bar spiral glitters blue where massive clusters have just assembled. In optical, dust rakes the lanes like claw marks. In the mid-IR, warm polycyclic features trace the photodissociation skins of giant clouds. In the far IR and submillimeter, cold dust writes the longer story of fuel. Radio maps extend the narrative beyond starlight. Neutral hydrogen drapes well past the optical disk and spills into a detached plume, the kind of starpore debris tides love to leave behind. Molecular tracers concentrate along the bar and the inner arm, where orbit families intersect and crowd. There, turbulence climbs, cloud lifetimes shorten, and the initial mass function gets a steady supply line. The hooked disk is also a time machine for stellar evolution. Massive stars born in the compressed arm live fast and die as core collapse supernovae within the very neighborhoods that knitted them. Their blast waves punch cavities and seed magnetic order, carving superbubbles that vent along the easiest gradients. Elsewhere, older populations orbit quietly, and when a white dwarf in a tight binary tips into runaway thermonuclear burning, the flash arrives from a calmer, more metal-rich suburb. Two different endings, gravitational collapse and carbon detonation, have already lit this system, turning the fishhook galaxy into both a forge and a yardstick. Look closely at the magnetic geometry of the southern hook and you find order inside the apparent disorder. Polarized emission tends to align with dust lanes where shocks stretch and straighten field lines, while tangled, depolarized patches coincide with stellar nurseries that have been stirred by winds and supernovae. That structure matters. Magnetic tension helps steer cosmic rays, couples gas to larger scale flows, and can even delay or promote collapse depending on how strongly it threads a cloud. In the Harpoon galaxy, gravity sets the stage, but magnetism and feedback write the choreography of the small scale. Star formation efficiency changes from place to place across the Volan spiral. Where the arm is compressed, the gas depletion time shortens. In the sheared outer hook, clouds struggle to stay bound long enough to form clusters. Age gradients creep along the arc, the youngest knots near dust shocks, slightly older associations downstream, and redder field stars further yet, a conveyor belt driven by the pattern speed. Even the clusters themselves tell the tale, compact, bright, ionizing groups shoulder to shoulder with looser, fading associations whose O stars have already burned out, leaving behind B stars and the first compact remnants. Beneath the spectacle of blue knots and ochre dust lies a quieter ledger of metals and angular momentum. The asymmetric barred spiral likely holds a shallow metallicity gradient bruised by mixing. Tides are good at moving both stars and gas, and inflows along the bar can raise central abundances while outer loops dilute. The disk-specific angular momentum, meanwhile, still betrays its disk ancestry. Most stars orbit in the same sense, even if their epicycles have been widened by the past encounter. Lopsidedness, in this sense, is not an identity but a phase, one act in a longer play of secular evolution and occasional flybys. Seen edge-to-edge in deep exposures, the meat hook's outskirts feather into faint streams and plumes that barely register above the background. Those low-surface brightness structures are tidal ink, loops that trace the relative mass and orbit of the perturber, and the time since pericenter. Modelers can dial in bar strength, halo shape, and encounter geometry until synthetic hooks match the real one, then read off a likely timeline, an approach that turns a pretty asymmetry into a dynamical chronometer. The southern hook is not merely photogenic, it is instructive. Because its disk survives and its bar is strong, it bridges the regimes of violent and gentle evolution. Bar torques, resonance rings, shock fronts, shear, feedback, magnetic ordering, tidal stirring, all can be studied within a single target whose nickname is as memorable as its physics. Call it the meat hook, the harpoon, the Volan's hook, the hooked spiral, the lopsided bar disk, each alias points to another facet of the same system, a galaxy caught mid-conversation with its environment, speaking in the grammar of rotation and resonance, punctuated by starbursts and supernovae, and legible from radio to X-rays to anyone willing to read across the spectrum. Along the crooked bar of the Volan's hook, orbit families crisscross like braided streams, and where those paths crowd, clouds collide and stick, raising the local pressure until molecules survive and collapse in earnest. The brightest clumps along the sharpened arm are the visible punctuation of that process, short-lived sentences written by O-stars whose radiation sculpts pillars and scalloped rims that face into the oncoming flow. Downstream, the grammar changes, ionized bubbles merge, stellar winds punch chimneys, and dust lanes that once looked like knife cuts thaw into filamentary lace as feedback and shear unravel the knots that birthed them. The hooked spiral looks lopsided to the eye, but its internal clock runs everywhere, advancing clusters from embedded infancy to gas-cleared adolescence in a few tens of millions of years, then dispersing them into the field as the pattern sweeps on. Tides did not just bend the arms of this harpoon galaxy, they also stirred the pantry. Gas that once orbited sedately in the outskirts now meanders inward along the bar in elongated loops, bleeding angular momentum into the stellar backbone and pooling near resonances where orbits stall. There the nucleus becomes a refinery, funneling, shocking, and heating the inflow until it fragments into star-forming rings and miniature spirals that dust renders as coffee-dark swirls. The engine hums without needing a quasar, a modest bar torque can keep it fed, and the lopsided outer arm ensures the queue never quite runs dry. From the halo's point of view, the whole exercise is bookkeeping. The dark envelope keeps the rotation flat and the disk stable enough to survive the scuffle, while the visible matter shuffles inward a little, outward a little, and writes new light where gravity allows. Look at the southern hook in polarized radio light and you'd expect to see the field lines combed along dust lanes, ordered where shocks stretch them taut, scrambled where clusters froth the gas. That magnetic scaffolding does more than decorate the picture, it guides cosmic rays and regulates how quickly clouds shed their support to collapse. In places where the hook is compressed, the field aligns and star formation proceeds briskly with short depletion times, where shear winds, turbulence and magnetism tie enough knots to slow the conversion of gas into stars. The result is a patchwork efficiency map stitched to the dynamics, a bright, efficient inner segment, a kink where tides have twisted the spiral, and a paler outer sweep where clouds struggle to stay bound. Even the debris beyond the starlight carries the system's memory. Neutral hydrogen hangs past the optical edge and spills into detached clumps, a ghostly ledger that tides keep more faithfully than stars. Those cold streams trace the past encounter like chalk marks on a floor, arcs that point to the perturber's path, gradients that reveal which side was compressed and which was stretched, spur features that only appear when the geometry was just so, nearly prograde, not quite head-on. Modelers replay the scene with bars of varying strength and halos of different shapes until a synthetic meat hook mirrors the real one, then read off a plausible timeline measured not in years but in pattern rotations and pericenter passages. On smaller scales, the Volan's bar spiral doubles as a laboratory for cluster demographics. Along the bright arm, beads on a string, clumps repeat with a cadence set by the competition between gravity and shear. Their colors drift subtly along the flow, from blistering blue and H-alpha bright upstream to slightly older, dust-softened associations downstream. The clusters do not age in isolation, winds knit them into shells, supernovae lace them with heavy elements, and leakage of ionizing photons etches translucent skins on adjacent clouds. Over time, the arm becomes a conveyor belt whose cargo is not gas but stellar populations, feeding the disk with field stars that remember the hook only in their kinematics. For observers, this distorted barred spiral rewards every wavelength you throw at it. In ultraviolet it is all spark and spray, young populations marking the freshest compression zones. In optical, ochre dust cleaves the bar and arms into dramatic relief. In mid-infrared, PAH bands and warm grains paint the photodissociation fronts. In far infrared and submillimeter, cold dust maps the hidden reservoirs. In the 21 cm line, extended hydrogen reveals the tidal handwriting no broadband image can show. Stitch those views together and the harpoon stops being an odd shape and becomes a story you can follow, a disk nudged by a neighbor, a bar doing secular work, gas obeying torques and shocks, stars lighting the aftermath, and gravity setting the meter that keeps the whole sentence grammatical. The hooked spiral is therefore less an anomaly than a chapter in the ordinary life of disks, one where an external nudge amplifies the internal bars and spiral's engine instead of erasing it. Call it the meat hook, the harpoon, the Volan's hook, the lopsided disk, the southern hook, the distorted bar spiral, whichever alias you choose, the physics underneath is the same steady duet of order and disturbance. Rotation supplies the scaffold, tides add a twist, magnetic fields and feedback refine the details, and out of that choreography comes a galaxy that looks wild at a glance but reveals, under patient study, how resilient a spinning sheet of stars and gas can be. On the scale of orbits, the hooked spiral carries an obvious m=1 lopsidedness, a global slant that rides on top of the familiar two-armed pattern. That one-armed asymmetry shifts the center of mass a little off the photometric core and skews the phase of density waves, so shocks and star formation don't appear symmetrically on opposite sides. Near corotation, you can watch the gas make a choice. Some parcels slip outward along feathered spurs and fade into the pale outskirts, others dive inward along the bar where orbit families crowd and the shear briefly slackens. The end result is a disk that keeps time to the same rotation curve as any normal spiral, while its accents, compressions, dust lanes, UV sparks, fall out of sync in a way that gives the Volan's hook its unmistakable silhouette. The harpoon galaxy's inner few kiloparsecs behave like a secular engine with variable intake. Bar torques bleed angular momentum from cold gas, guiding it into lanes that hug the leading edges and ram it through standing shocks. Downstream, the material cools into molecular clouds and lights up in clusters. Where an inner Lindblad resonance lurks, inflow stalls into a pseudo-ring, a coffee-dark loop whose embedded spirals feed the nucleus with just enough fuel to sustain a modest starburst and a restless interstellar medium without tipping the system into quasar theatrics. The engine's efficiency isn't constant. whenever tides wrinkle the outer pattern, the intake surges, and the hooked spiral breathes a little harder. In the meat hook's brighter arm, the star-forming beads are spaced by a balance between self-gravity, shear, and feedback pressure, so their cadence doubles as a seismograph of local dynamics. Upstream rims glow in H-alpha where gas first shocks. A few hundred parsecs downstream, dust cocoons break into scalloped shells, and further along, the UV light softens as O-stars age out and B-stars take over. The sequence repeats like measures in a song written by the pattern speed. Across the fainter arm, shear wins more often, clouds are stretched, pillars are shorter-lived, and clusters emerge looser and less massive, a demographic echo of how different the two sides of the Volan's harpoon really are. Magnetism threads the picture with quiet authority. Polarized radio emission tends to line up with dust features on the concave side of the strong arm, proof that shocks have combed the field into order, while depolarized patches coincide with frothy H2 complexes where turbulence tangles lines faster than they can align. Those fields help set the effective pressure in clouds, steer cosmic rays into chimneys that vent superbubbles, and influence how quickly a compressed ridge actually collapses. In the southern hook, gravity writes the score, but magnetism conducts the small-scale orchestra. Beyond the bright disk, the fishhook galaxy carries its past in gas rather than in stars. Neutral hydrogen extends well outside the optical body and spills into detached clumps that barely form any luminescent knots, a sign that the tides that sculpted the hook were efficient at peeling gas while leaving the stellar disk intact. The kinematics in those outskirts don't perfectly trace circular motion, gradients tilt and twist in ways that sketch the geometry of the old encounter, likely a not quite head-on, nearly prograde pass. Modelers replay such flybys with bars of different strengths and halos of varying flattening until a synthetic hook reproduces the observed plume and arm curvature, then read off a timescale measured in pattern rotations rather than calendar years. Chemistry and mixing tell a subtler version of the same story. Radial inflow along the bar tends to enrich the center, while tidal stirring and outer plumes dilute the periphery. The net effect is a metallicity gradient shallower than a quiet spirals, stippled by local highs where feedback has recycled metals into the next generation of clouds. Dust follows suit. Warm mid-infrared bands mark photodissociation skins around young clusters, colder far-infrared emission maps reservoirs that won't light up until the next compression sweep. Energy balance across wavelengths, UV, H-alpha, mid-IR, far-IR, lets you count the hidden stars the dust is hiding and shows that the Volan's hook converts gas into starlight fastest where the bar meets the dominant arm. The distorted barred spiral in Volan's doubles as a training ground for stellar death as much as for stellar birth. Core collapse events are expected along the tight, shocked segments where massive stars live fast, while thermonuclear supernovae appear from older neighborhoods with calmer kinematics, giving the same galaxy two very different clocks to time. Their remnants punch cavities, seed magnetic order, and lace nearby clouds with heavy elements, changing the opacity and cooling curves for the next round of collapse. In this way the hooked disk writes successive drafts of itself, each supernova both an ending and a set of edits to the interstellar script. Even the dark sector leaves fingerprints on the hooked spiral's resilience. A massive, relatively round halo keeps the rotation curve flat and stabilizes the disk against complete disruption, so the lopsidedness remains a bruise, not a break. The global specific angular momentum of the stars still matches that of a disk that spun up in a quiet cosmic web, even if the epicycles are a bit wider now. That combination, robust rotation supported by an unseen scaffold, visible matter temporarily out of phase because of tides, is why the Volan's hook can look so wild and yet fall back into the same scaling relations that ordinary spirals obey. Call it the meat hook, the harpoon, the Volan's hook, the hooked bar disk, the southern hook. Under every alias it remains a living demonstration of how galaxies evolve, by steady rotation punctuated by nudges, by bars doing secular work while encounters add drama, by magnetism and feedback sculpting the small scale while a dark halo keeps the stage from collapsing. The next deep exposure or longer radio integration won't change that melody, it will simply reveal more notes, fainter plumes, subtler age gradients, quieter shells, filling in the score of a disk that has been bent, not broken, and is still busy turning cold gas into new light. Walk the outer curve of the fishhook and the surface brightness falls to whispers, but the physics gets loud. Out there, the tumor balance between self-gravity and shear wobbles right on the edge. A little extra compression from the passing pattern tips gas into collapse, a little extra epicyclic kick stretches clouds into ribbons before stars can gather. The result is a lacework of filaments and faint knots that marks the transition from a star-forming disk to a realm governed by stability criteria rather than by fuel alone. In the same territory the pattern speed leaves its fingerprints. Feathers peel from the main arm at regular phase intervals, a fossil record of where the density wave once nudged the medium hardest. Back toward the bar of the Volan's hook, orbit families change character and so does the chemistry. Inflowing gas meets shocks, the molecular fraction jumps, and cooling times plummet, turbulence rises just enough to fragment without completely shredding the nascent cores. Feedback arrives on schedule, winds, radiation pressure, then the first supernovae, raising the effective pressure and briefly throttling the efficiency until the next sweep of the pattern resets the stage. The cycle is secular, torques gather material, shocks ignite clusters, feedback scours, and the bar keeps time. Magnetic fields in the Harpoon galaxy act like an invisible truss. Where dust lanes are straightest, polarization would reveal long, ordered runs that help channel charged particles and stiffen cloud envelopes. Where H2 complexes froth, depolarization betrays tangled lines and fast reconnection. That scaffolding decides whether a compressed ridge fails gracefully into filaments or catastrophically into a beadwork of clusters, and it helps carve chimneys through which hot gas and cosmic rays vent, linking the disk to a more tenuous halo you only see in X-rays and radio. The hooked spiral is also a classroom for angular momentum bookkeeping. Gas sliding along the leading edges of the bar trades spin for binding energy. Stars born from that gas inherit cooler, more elongated orbits, while older populations keep the warmer kinematics of an earlier epoch. Over gigayears, that subtle sorting builds the inner morphology we see, oval flows, mini-rings, nuclear spirals, without ever needing a blowout or a quasar to rearrange the furniture. It is the quiet triumph of secular evolution playing a duet with an old tidal nudge. Chemical abundance patterns in the meat hook are expected to be modeled rather than monotonic, the signature of inflow, mixing, and feedback happening on overlapping timescales. Pockets near the bar ends show higher metallicity where gas has been cycled more often, outer swaths run lower thanks to dilution by tidally stirred reservoirs. Dust follows the money, mid-infrared bands light up the photodissociation skins of cloud complexes along the sharp arm, while far-infrared and sub-millimeter emissions sketch colder stockpiles in the kinked, sheared sweep on the opposite side. Star clusters along the bright arc age like tree rings stretched into a spiral. Upstream, blistering blue groups still wrapped in patchy dust, a little downstream, shells and superbubbles with O-stars already thinning out, farther yet, associations dominated by B-stars and redder field light filling in the gaps. Measure their colors and sizes and you recover the cadence of the underlying wave, a natural clock that dates not just individual knots but the speed at which the harpoon's pattern writes across the disk. Even the parts that look empty in broadband images aren't idle. Low surface brightness HI around the lopsided bar disk preserves the geometry of the long-gone encounter better than the stars do. Slight twists in outer velocity contours reveal where the past perturber tugged hardest. Simulations that match those kinematic quirks point to a not quite head-on, nearly prograde brush, strong enough to bend an arm, not strong enough to unmake a disk, exactly the kind of cosmic bump that turns a quiet spiral into the memorable silhouette we now call the Volan's hook. In the long forecast, nothing about the fishhook's fate is catastrophic. The dark halo keeps the rotation curve flat and the sheet resilient. The bar will continue to wick gas inward and light compact circumnuclear spirals. The strong arm will keep stamping out beadwork where shocks run cleanest. The faint arm will keep trading brilliance for breadth as shear stretches what gravity tries to gather. If a former companion loops back for another pass, the choreography will sharpen. If not, secular processes will slowly round off the bruise into a more symmetric disc, leaving only the faintest plumes in the outskirts as a memory. Call this system the meat hook, the southern hook, the harpoon, the hooked bar spiral. Every alias fits because each name's a different register of the same instrument. Rotation holds pitch, tides add harmony, bars set rhythm, magnetism tunes the small-scale timbre, and feedback improvises over it all. What looks like a cosmic accident from afar is, up close, a resilient machine turning cold gas into new light with clockwork regularity, even as a single, dramatic arm keeps reminding us of the moment a neighbor's gravity nudged the melody into its unforgettable shape. Astronomers read the hooked spiral like a score by measuring how patterns move through it. One way is the Tremaine-Weinberg trick. Treat bright tracers as beads on a conveyor belt and infer the bar's pattern speed from how light and velocity line up along slits. In a system like the Volan's hook, corotation tends to fall near the kink where the dominant arm changes pitch. Inside that radius gas drifts inward along the leading edge shocks of the bar, outside it peels outward into feathers. Translate those kinematic cues into timescales and you get a rhythm of a few pattern rotations per few 100 million years, long enough for tides to bruise the disk yet short enough that the bar keeps the engine running between encounters. Star clusters along the sharpened arc obey familiar demographics. Count them by mass and you recover a near power law distribution with a slope close to -2, meaning there are many more modest groups than giants, but the giants that do appear grab your eye in most of a UV. Their lifetimes trace environment. Near the bar ends, stronger tides and higher pressures prune fragile associations early, infant mortality, while in the quieter outer sweep, looser groups drift apart more gently. The result is a color and size gradient that doubles as a travel diary for each bead on the string, blistering blue and compact upstream, shell-rimmed and slightly redder downstream, then dissolving into the field. The interstellar medium in the meat hook behaves like a three-phase ledger. Dense molecular gas piles up along dust lanes where shocks and bar torques compress it. That reservoir glows in CO and feeds the most efficient cluster factories. Surrounding it sit CO faint, dark H2 traced better by C2, and far IR dust emission, common where UV fields nibble at cloud skins. Farther out, atomic hydrogen dominates, kinematically colder than the stars but easily stirred by tides. Plot gas surface density against star formation rate and the system lands on the Kennicutt-Schmidt relation on average, yet patch by patch the slope bends with dynamics, steeper where inflow concentrates fuel, flatter where shear stretches clouds before they can collapse. Dust grains tell the small-scale weather. Along the knife-edge arm, PAH bands weaken right behind the hottest clusters, tiny molecules shattered or ionized by hard radiation, while slightly downstream warm, very small grains re-radiate starlight in the mid-IR and cold silicates carry the far-IR load. In shocks, big grains can fracture into smaller ones, in quieter pockets they coagulate back into fluffier aggregates. Those microphysics modulate how quickly gas cools and how readily clouds shield themselves, feeding back into where the next round of stars will appear. The harpoon's photogenic clumps are, in part, dust chemistry made visible. Cosmic rays and magnetic fields lace the fishhook with invisible structure. Where the field is combed along dust lanes, synchrotron emission brightens and the spectral index flattens, freshly accelerated electrons and ordered lines. In frothy H2 complexes, turbulence tangles the field, depolarizing radio light and steepening the spectrum as electrons age. Superbubbles vent along the path of least magnetic resistance, opening chimneys that couple the disk to a faint, warm halo. Even without a quasar's fury, the hooked spiral leaks energy upward, it just does so through many small valves rather than a single blowtorch. Dynamically, the lopsidedness rides on swing amplification and tidal prompting. A near prograde flyby seeds an M=1 mode, the bar then shears, compresses, and rephases that disturbance into the single dominant arm we see. Over several rotations, the asymmetry decays unless another nudge arrives, but its aftereffects, redistributed angular momentum, mixed metals, migrated stars, linger longer. That's why the Volan's hook can look wild in starlight yet sit comfortably on disk scaling relations. The dark halo keeps the scaffold stiff while the luminous matter slips temporarily out of phase. Chemically, the system carries the signature of both inflow and stirring. Central gas tends to be more metal-rich where the bar has cycled it repeatedly. The outer kink and detached HI clumps red lower because of dilution by tidally stirred reservoirs. Local spikes appear around superbubbles where fresh heavy elements seed the next clouds. Stitching those patches into a gradient recovers a slope shallower than in a perfectly calm spiral, a quiet fingerprint of mixing by bars and tides rather than by mergers. Compared to classic interaction pairs like M51, the southern hook sits in a gentler regime, no grand two-arm symmetry, no overwhelming companion torque, just a stubborn bar and a memory of a brush-by. That makes it ideal for testing how internal, secular processes and external nudges add rather than substitute. You can watch bar inflow build a pseudo-ring without erasing the disk, see bead spacing respond to shear without global collapse, and measure how HI plumes remember the flyby after starlight has forgotten. The next instruments sharpen different chapters of the same story. Millimeter arrays resolve cloud life cycles along the strong arm, separating prestellar cores from feedback-shocked shells. Sensitive low-frequency radio maps trace aged cosmic rays bending around the outer hook. High-resolution infrared imaging counts embedded clusters where optical dust lanes go opaque, tying age sequences to exact shock offsets. Each wavelength fills another line in the ledger of a galaxy that, whatever name you give it, the meat hook, the Volan's hook, the harpoon, the hooked bar disk, demonstrates how a rotating sheet of stars and gas can take a cosmic nudge, bend into an unforgettable shape, and keep calmly manufacturing light. Out in the pale outskirts of the southern hook, the disk enters a regime where stability is negotiated, not guaranteed. The Tumor Q parameter hovers near unity. Slight boosts in surface density from the passing pattern or from epicyclic crowding can tip filaments into collapse, while a nudge of shear unspools the same filaments back into the diffuse medium. That push-pull writes a fractal shoreline of star formation, tiny OB associations lighting one ridge while the next ridge dissolves into HI spray, a living map of how rotation and turbulence arbitrate what becomes a cluster and what returns to drift. Closer in, the bar end region is a natural laboratory for orbit crowding and gas shocks. There, families of X1 type orbits funnel material along the leading edges, and as the stream bends into the arm, the flow rams a standing shock that piles up dust just upstream of the brightest H2 knots. The offset between the dust lane and H-alpha glow doubles as a clock, the time it takes compressed gas to cool, molecule-rich pockets to form, and massive stars to switch on. Measure that offset along the hooked arc and you can back out both the pattern speed and the local efficiency with which the inflow turns fuel into newborn clusters. The lopsided bar disk also records mixing in its chemistry. Inflow raises central abundances by recycling previously enriched gas, while tidal stirring and the long outer sweep dilute metallicity on the opposite flank. Resolved spectra should show shallow gradients peppered with local plateaus around superbubbles where fresh heavy elements are re-injected. Dust responds in kind. PAH features weaken right behind the most intense UV sources, mid-infrared continua brighten in their wake, and the far-infrared quietly totals the colder inventory that will feed the next shock-triggered burst. Clumps along the sharpened arm follow the familiar, beads on a string, cadence set by the competition between gravity and shear. Their masses and radii sketch a near power law census with many modest associations and a few headliners that anchor the UV image. Age gradients drift along the flow, ionization fronts hard and blue at the shock, shell-rimmed clusters a few hundred parsecs downstream, then looser groups whose O-stars have already burned out. By the time those populations fade into the field, kinematics, not color, holds their memory of the meat hook's bright arc magnetism underwrites much of this choreography. Polarized synchrotron ridges tend to align with the concave side of the strong arm where shocks have combed the field straight, while depolarized, tangled zones track frothy H2 complexes. Ordered fields stiffen cloud envelopes and guide cosmic rays into chimneys, helping superbubbles find vertical escape routes without shredding the arm. The net effect is to accelerate feedback where compression is clean and to slow collapse where shear and tangled lines dominate, a patchwork map of star formation efficiency stitched to the dynamics. Kinematically, the Volans hook is a textbook in mild disturbance. Harmonic decomposition of its velocity field would show non-circular streaming along the bar, a twist in the major axis across the arm kink, and gentle asymmetries in the outer rotation that betray the old tidal tug. Yet the rotation curve still rises and flattens like a healthy disk pinned by a massive halo. Scaling relations that tie luminosity to line width remain intact because the scaffold, dark matter plus ordered spin, never gave way, even while the luminous material fell temporarily out of phase. On cloud scales, a full life cycle plays out along a single sweep of the harpoon. Prestellar condensations gather in the dust lane upstream, embedded clusters ignite and begin pushing back, winds and radiation pressure carve shells that merge into superbubbles. The next inflow encounters a pre-stirred medium whose turbulence spectrum has already shifted. Millimeter interferometers pick apart this sequence by isolating dense gas tracers from more diffuse CO emission, while far UV through near-IR photometry ties each knot's age and extinction to its place on the conveyor belt. The faint gas beyond the starlight keeps the encounter's ledger more faithfully than the stars do. Extended HI drapes past the optical rim and spills into off-disk clumps that form few if any clusters, implying that tides peeled gas more efficiently than they displaced the old stellar population. Subtle twists in the outer velocity contours point to a nearly prograde, slightly off-center brush, strong enough to bend one arm into a harpoon, not strong enough to unmake the disk. Numerical flybys that match the plume geometry naturally reproduce the arm's unequal pitch angles and the bar's current torque budget. Even without a blazing nucleus, the hooked spiral vents energy upward. Hot superbubble interiors leak through low-density corridors set by field geometry, faint, warm ionized gas glows in diffuse halos, aged cosmic ray electrons sketch soft radio cocoons that mirror the arm's curvature at larger radius. This gentle, galactic breathing couples the disk to its surroundings and seeds the circumgalactic medium with metals and magnetic flux, a slow-motion exchange that proceeds through many small valves rather than any single outburst. Call it the meat hook, the harpoon galaxy, the Volans hook, the southern hook. Under every nickname it remains a resilient machine whose apparent drama is just gravity's patience made visible. A bar bleeds angular momentum, a past nudge sets an m=1 slant, magnetism and feedback sculpt the small scale, and a dark halo keeps the rhythm. From dust lane clocks to HI plumes, from polarized ridges to age-graded beads, the system offers one of the cleanest chances in the nearby universe to watch a spinning sheet of stars and gas absorb a cosmic shove, bend into an unforgettable silhouette, and keep calmly manufacturing light. Out beyond the bright hook, the debris that tides once peeled away doesn't simply disperse, it drifts, slows, and sometimes rains back in, a quiet galactic monsoon that seeds the next cycle of star formation. Reaccreted streams arrive with off-kilter angular momentum, thickening the outer disk and nudging the lopsided pattern to persist longer than a single flyby would suggest. In that slow exchange between disk and halo, the harpoon keeps its asymmetry alive not by force, but by habit, fuel delivered slightly out of tune with the underlying rotation. Photometrically, the hooked spiral wears its dust like a mask that changes the scene depending on wavelength. Blue light exaggerates the bruise, strong extinction across the knife-edge arm and a paler, sheared sweep opposite, while the near-infrared reveals the bar's older backbone almost symmetrically, reminding you that the stellar mass map is calmer than the star formation map. Correct for that dust and the underlying disk look surprisingly regular, leave it in place and the drama of shocks, cocoons, and shells tells the day-to-day story of gas learning the bar's grammar. Stellar populations in the southern hook mix like layers in sedimentary rock laid down by a tide that arrives every rotation. Young clusters, a few million years old, line the concave edge of the dominant arm. Intermediate age associations trail behind like foam. Redder giants collect toward the bar and inner oval where orbit families overlap. The metallicity pattern is mottled but shallow in slope, a fingerprint of inflow enriching the center while tidal stirring and outer plumes keep the outskirts from running too far ahead or behind. Dynamically, the fishhook's outline can be understood in terms of the manifolds that emanate from the bar's ends, cosmic exit ramps at the Lagrange points where orbits peel off into trailing lanes. On one side those streams stay cohesive and bright, corralling gas into a single dominant arm, on the other, shear and a slightly different phase scatter them into feathers. The result is a system that looks like a rule breaker but is actually following the bar's geometry with textbook obedience. Compared with classic showpieces like the whirlpool, this lopsided bar disk sits in a subtler regime, where a modest external nudge amplifies internal structure rather than overwhelming it. That's why the Volan's hook is so valuable theoretically. It lets you separate what bars do on their own, bleeding angular momentum, building pseudorings, feeding circumnuclear spirals, from what a neighbor adds, an M=1 slant, a kinked outer arm, stray HI plumes that remember the encounter after starlight forgets. Supernova archaeology along the bright arc adds time-stamped footnotes to the narrative. Core collapse remnants expand into pre-stirred cavities, lighting rims where winds and shocks have already lowered the density. Thermonuclear events pop up from older, quieter neighborhoods, serving as standard candles that, almost incidentally, measure a distance to the hook while its own physics plays out. Each blast slightly re-edits the interstellar medium, a handful of new metals here, a reshaped magnetic corridor there, small changes that add up when counted across 100 million years. The central engine doesn't need a quasar to matter. A bar-fed, ring-like inflow can maintain a compact starburst and a restless, clumpy interstellar medium whose turbulence keeps cloud lifetimes short and collapse efficient right where orbit families crowd. If the bar ever slows, as it trades angular momentum with the dark halo, the resonances migrate outward, and with them the ring. The refinery moves its address but keeps refining just the same. On vertical scales, feedback lifts warm gas and cosmic rays into a faint halo shaped by field geometry rather than brute force. Superbubbles punch chimneys where magnetic tension yields, and the outflow drifts rather than roars, seeding the circumgalactic medium with metals and flux. Later, some of that material cools and falls back, closing a fountain cycle that keeps the harpoon's outskirts chemically alive without needing a merger to stir the pot. Observers can read different chapters by choosing their light. Galax-like ultraviolet frames announce where compression has just paid off. H-alpha sketches the ionization fronts with surgical clarity. Mid-infrared bands reveal photodissociation skins where tiny grains and PAHs glow. Far-infrared and submillimeter maps weigh the cold reservoirs that tomorrow's beads will draw from. 21-centimeter radio contours pull back the curtain on the gas the stars haven't yet claimed. Put those layers together and the meat hook ceases to be a curiosity and becomes a ledger, each wavelength a column in the accounting of torque, shock, collapse, and feedback. Even for backyard telescopes in southern latitudes, the crooked bar is a rewarding quarry. Under dark skies, the brighter arm shows a hint of curvature, and long integrations begin to suggest the unequal twins that earned the system its nicknames. Narrowband filters tease out the scattered knots, careful processing pulls the faint outer sweep into view. Amateur data, stacked patiently, end up echoing the same asymmetry that professionals quantify with interferometers and integral field spectrographs, a democratic galaxy, photogenic at any aperture. In the long view, the southern hook's fate hinges on patience. Absent a disruptive merger, the bar will continue to wick gas inward, the strong arm will keep stamping out cluster beadwork where shocks run cleanest, the sheared side will remain the place where clouds almost, but not quite, hang together, the HI plumes will thin as reaccretion and ionization erode their contrast. Given time, the bruise may soften, but the disk will remember, slightly wider epicycles, a shallower gradient, a bar that has migrated and perhaps buckled into a low-contrast boxy bulge, all quiet testimonies to a nudge absorbed rather than a structure destroyed. Call it the meat hook, the harpoon, the Volan's hook, the southern hook, the hooked spiral, the aliases are many because the facets are many. Under every name you find the same resilient machine, a rotating sheet kept honest by a dark scaffold, tuned by a bar, tilted by an old encounter, and refined by magnetism and feedback into a patchwork of shocks, clusters, shells, and plumes. What first looks like a cosmic accident resolves into a system obeying clear rules, only offset, delayed, and braided, so that gravity's grammar can write an unforgettable sentence in the shape of a single, dramatic arm. Seen in integral field spectra, the hooked bar spiral resolves into a quilt of excitation regimes that trace its internal weather. Along the knife-edge arm, line ratios stack into classic H2 signatures where young clusters flood their cocoons with photons. Just upstream, shocks betray themselves with enhanced low ionization lines as gas slams into the standing front. Deeper toward the bar, composite zones hint at mixed illumination where older populations and diluted radiation fields overlap. Stitching those diagnostics along the flow turns the meat hook into a moving laboratory. Ionization, shock strength, and density all change in step with the pattern, a choreography written by torque and shear rather than by chance. Underneath the glowing tracers, the mass skeleton is calmer. In the near-infrared, the bar's old stars form a fairly symmetric spine. The obvious asymmetry belongs mostly to dust and gas, not to the ancient stellar disk. That contrast matters. It explains how the harpoon can look wildly lopsided in blue light yet keep stable rotation and a tidy relationship between luminosity and line width. The dark halo holds the tempo, the old stars carry the bass line, and the gas solos, loudly, brilliantly, and briefly, where the conductor, the bar, cues a crescendo. Cloud life cycles along the bright arc read like a conveyor belt of cause and effect. Compression in the dust lane spawns dense clumps. Within a few mere, the first O-stars ignite and begin to dig, their winds and radiation pressure clearing cavities that merge into scalloped shells. Supernovae follow, welding shells into superbubbles and seeding fresh metals into the surrounding medium. By the time the next wave of inflow arrives, turbulence has been pre-stirred, magnetic fields have been stretched, and cooling curves have shifted. Conditions that either accelerate or delay the next collapse depending on how closely the new gas retraces the old paths. At the ends of the bar, orbital manifolds act as cosmic exit ramps, guiding streams into trailing lanes. On the side that becomes the dominant arm, those manifolds stay cohesive long enough to shepherd gas into a single bright strand. On the opposite side, a small phase offset and higher shear shred the streams into feathers. That geometry is enough to explain the harpoon silhouette without invoking a heavyweight intruder. A modest flyby planted the seed, but the bar's own dynamics amplify and sustain the one-armed show. If the bar trades angular momentum with the halo and slows, a secular inevitability, its resonances will drift outward. The circumnuclear pseudoring will migrate, the beat of inflow will change key, and the pattern speeds of arm and bar will rephase. None of that demands fireworks. It is evolution by ledger, a few percent off the bar's speed here, a gentle outward slide of resonances there, a gradual reshaping of where the hook stamps out its beads. The outer disk of the Volan's hook is a classroom for marginal stability. There, Tumor's cue hovers around unity and small nudges decide outcomes. An extra dollop of surface density from a feather tips a filament into collapse, a smidge more shear unravels it. That balance imprints a fractal frontier of star formation, faint knots and half-erased filaments etched into HI, so sensitive to phase that two adjacent ridges can live radically different fates despite nearly identical ingredients. Metallicity across the hooked disc tells a story of mixing rather than of monotone gradients. Inflow along the bar recycles enriched gas into the center, tidal stirring and outer plumes dilute the far side. Local peaks bloom around superbubbles where fresh heavy elements have just been minted. The slope ends up shallower than in a quiet grand design spiral, but the patchwork is richer, chemical weather tied to dynamical seasons. Magnetic fields thread this narrative with quiet discipline. Polarization ridges align with dust lanes where shocks have combed the field taut, granting clouds a little extra stiffness against fragmentation. Depolarized patches coincide with frothy H2 complexes where turbulence tangles lines faster than they can realign. Cosmic rays surf those fields into vertical chimneys, venting energy into a faint halo that glows softly in radio and low surface brightness H-alpha. Even without an active nucleus, the harpoon breathes, upflows from many small valves, downflows as cooled gas rains back in, a fountain that slowly magnetizes and metals the circumgalactic medium. On longer timescales, stellar migration will soften the bruise. Transient spirals and the bar scatter stars at corotation, letting them swap angular momentum without heating the disk excessively. Over gigayears that mixing rounds off age and metallicity contrasts, leaving subtle kinematic signatures, slightly wider epicycles on the hooked side, a touch more vertical thickness where reaccreted gas settled out of plane, a boxy peanut hint if the bar eventually buckles. The memory of the encounter fades in color before it fades in motion. Observationally, the crooked spiral rewards patience and variety. Ultraviolet shows where compression just paid off. H-alpha traces ionization fronts with surgical edges. Mid-infrared PAH bands reveal the photodissociation skins. Far-infrared and sub-millimeter weigh the cold stockpiles. CO maps follow the dense reservoirs. 21 cm contours expose the plumes that stars haven't claimed. Add integral field kinematics to see the streaming, and polarized radio to read the field geometry, and every alias, meat hook, harpoon, Volan's hook, southern hook, resolves into facets of the same machine, a rotating sheet nudged off balance, yet stubbornly faithful to the grammar of disks. In that light, the galaxy's drama is not an exception to the rules but a demonstration of them. A gentle tidal shove awakened an m=1 slant, a bar did the steady work of torque and transport, magnetism and feedback set the small-scale tempo, a dark halo kept the stage from collapsing. What we see as a single, unforgettable arm is gravity writing in italics, same syntax, sharper emphasis, turning cold gas into new light with clockwork regularity while carrying, in its bent outline, a legible memory of the day a neighbor drifted too close. The southern hook is a natural census-taker of extremes, hosting both the soft glow of red supergiants and the needle-bright signatures of Wolf-Rayet stars in pockets where the compressed arm has just minted its most massive clusters. Those brief, helium-rich phases salt the spectrum with broad bumps and high excitation lines, a chemical flare that announces how top-heavy the most intense ridges can become for a few million years. Farther down the conveyor, the same clusters fade into OB associations, then into looser groups whose brightest voices shift from ultraviolet to blue, then to the redder light of aging giants. Follow that drift and you recover a star formation history written not in a single burst but in a sequence of overlapping beats, each tied to where the bar and spiral met at just the right angle to squeeze the gas. High-energy tracers add a sharper accent to the melody. Along the bright arc, point-like X-ray sources tally high-mass binaries born in the recent surge, while nearer the bar and inner oval, older low-mass systems contribute a steadier, quieter chorus. The few ultraluminous outliers, if present, would likely sit in the densest star-forming knots where massive progenitors and close binaries are common, carving tiny cavities and pushing on the local medium with jets and winds. Even without a blazing nucleus, the harpoon can be an efficient particle accelerator on cluster scales, and radio continuum maps reflect that, flatter spectra and brighter ridges where fresh electrons and ordered fields live, steeper and softer halos where the population has aged. Dust, so responsible for the hook's photogenic drama, is also a diagnostic instrument. In the knife-edge arm the attenuation curve can tilt grayer where turbulence mixes grains of many sizes, muting the classical 2175A bump. Downstream, as shells merge and UV fields soften, the small aromatic carriers that power mid-infrared bands recover, lighting the photodissociation skins of cloud complexes. Grain growth and shattering play out in step with the dynamics, shocks fracture larger particles into fresh small grains, quiet intervals let them coagulate back into fluffier aggregates that cool gas efficiently and help the next round of collapse to proceed. Vertical structure gives the lopsided disk a quiet third dimension. Reaccreted streams with slightly misaligned spin thicken the outskirts into a mild flare, while superbubbles ventilate the bright arm and leave chimneys that lift warm ionized gas a kiloparsec or two above the plane. Polarized emission often outlines those escape routes, implying that the field geometry, not brute force, sets the valves through which energy and metals leak into the halo. Over time the fountain closes its loop, some gas cools, settles back with a small lag in angular momentum, and quietly feeds the next pass of the pattern. Environment explains the system's poise. The Volan's hook doesn't live in a crushing cluster where ram pressure scours disks, it keeps company with a few modest neighbors whose tides can bruise without breaking. That's the sweet spot for asymmetry that lasts. A nearly prograde brush to seed an M=1 slant, enough mass in the perturber to peel an HI plume, a strong internal bar to amplify one side into a dominant arm and to keep secular inflow humming while the outer disk rides out its wobble. The absence of wholesale disruption is why scaling relations stay honest even as the face of the galaxy looks wild. Dynamics inside the bar continue to refine the picture. As the stellar backbone trades angular momentum with the dark halo, its pattern speed drifts and resonances migrate outward, carrying the circumnuclear pseudoring with them like a rippling traffic circle. New orbit families turn on as others fade, subtly rephrasing where gas stalls and where it streams. None of this requires fireworks, the refinery keeps working, just moving its address in slow motion, and the hooked silhouette above it keeps stamping out beads where shocks run cleanest. Cloud life cycles along the strong arm resolve into measurable delays that double as rulers. The offset between the dust lane and the H-alpha bright ridge clocks the time from compression to ignition, the gap from H-alpha to peak mid-infrared emission measures how quickly young stars clear their cocoons, the softening of UV downstream dates the moment when O-stars hand the stage to longer-lived B-stars. Set those clocks against the local streaming speed and you read off the pattern speed and shear, turning a pretty image into a kinematic diagram you can hold in your head. Chemistry keeps pace with that choreography. Central gas grows incrementally more metal-rich where inflow recycles it through star-forming rings, the sheared, paler side of the outer disk trends lower thanks to dilution by tidally stirred reservoirs, localized peaks bloom around superbubbles where fresh heavy elements have just been minted and folded back into nearby clouds. The net gradient ends up shallow but stippled, a fingerprint of mixing by bars and tides rather than by major mergers. Even the apparent emptiness carries memory. In deep 21 cm maps, diffuse hydrogen drapes beyond the optical rim and into detached clumps with little or no starlight, a ledger entry that the stars have already forgotten. Those plumes and twists in the outer velocity field point to a not quite head-on, nearly prograde pass, strong enough to bend an arm into a harpoon, not strong enough to unmake a disk. Numerical experiments that reproduce the plume geometry naturally recover the unequal pitch angles and the present torque budget of the bar, linking a single snapshot to a plausible timeline measured in pattern rotations. For observers, the crooked bar rewards a multi-wavelength approach and a little stubbornness. Ultraviolet frames mark where compression just paid, H-alpha sketches ionization fronts with razor edges, mid-infrared bands trace the skins of clouds that hard radiation has nibbled, far-infrared and sub-millimeter weigh the cold reservoirs the next shock will tap, CO lines map the dense fuel along the lanes, polarized radio light reveals where fields are combed and where they're tangled, integral field spectroscopy ties the velocity story to the light. Stack those views and the meat hook, the harpoon, the Volan's hook, choose your alias, resolves into a single argument made many ways. A rotating sheet of stars and gas can take a nudge, bend into an unforgettable outline, and still keep time to gravity's steady beat as it turns cold matter into new light. On the scale of single clouds, the hooked spiral shows how geometry becomes destiny. Where the bar meets the dominant lane at a clean angle, orbit crowding makes shocks nearly steady, so clouds enter the compressor like logs through a sawmill and leave as dense, self-gravitating knots, where the angle is sloppier, shock stutter, turbulence wins, and the medium stays filamentary with only scattered, smaller clusters. That sensitivity explains why two segments with similar gas mass can differ so much in ultraviolet brightness. The harpoon does not just supply fuel, it sets the terms of conversion. Pressure, shear, and magnetic tension form a three-way negotiation whose outcome you can read in the cadence of beads, in the spacing of dust scallops, and in how quickly H-alpha hands the baton to mid-infrared glow downstream. The lopsided bar disk also demonstrates radial migration in real time. At corotation, stars exchange angular momentum efficiently with the pattern and drift without being violently heated. Over hundreds of millions of years, that quiet shuffling rounds off age and metallicity contrasts that tides first exaggerated. You end up with a population map that looks surprisingly smooth in the near-infrared even while blue light keeps advertising the asymmetry. The Southern Hook's lesson is subtle but general. Morphology can be loud while the mass distribution hums along in a lower, steadier key. Cold gas physics in the Volan's Hook rewards close bookkeeping. Dense gas tracers pile up along the dust ridge, but a substantial fraction of hydrogen hides in CO faint molecular skin that defeat simple calibrations. Far infrared and C2 pick up the slack by tallying photodissociation fronts that wrap each complex. Tie those to the local streaming speed and you recover a practical recipe. Where compression is clean and the field is ordered, the depletion time shortens. Where shear and tangled lines dominate, the same surface density buys less starlight. The hooked spiral is not starburst in the headline sense, yet in its best aligned segments it achieves efficiencies that rival the compact circumnuclear rings of more symmetric barred disks. The fishhook galaxy also hints at how bars evolve under the drag of their own work. As torques vary angular momentum outward, the stellar backbone slowly slows, resonances creep, the pseudoring migrates, and the inflow beat changes phase with the outer arm. If the pattern eventually buckles, the inner light will puff into a boxy peanut silhouette when viewed edge-on, a fossil of vertical resonances turning a flat bar into a thickened one. None of that drama is required to keep the harpoon's outline vivid. It is enough that the bar keeps time and tides keep the melody tilted. High-energy punctuation marks continue to edit the interstellar script. Along the bright arc, fresh supernova remnants expand into a medium the previous generation has already stirred, so shock fronts run faster along low-density channels and stall where compressed ridges remain. Those cavities herd cosmic rays toward vertical chimneys that polarized radio maps outline, connecting the disk to a warm halo where metals and magnetic flux accumulate by increments. Later, some of that cargo cools and returns as oblique drizzle, a fountain that thickens the outer sheet and quietly feeds the next round of compression along the hook. Even the apparent negatives, lopsidedness, unequal pitch angles, detached HI, turn out to be assets for theory. Because the perturbation was modest, the Volan's hook lands in a regime where internal dynamics dominate while the external nudge merely biases the outcome. That makes it a clean benchmark for manifold-guided spirals, for swing-amplified M=1 modes, and for secular inflow that builds circumnuclear structure without invoking a quasar. Compare this hooked spiral to Magellanic Type 1 arm systems or to classically symmetric grand designs, and you can watch how small differences in encounter geometry and bar strength decide whether a galaxy grows a single emphatic arm, two balanced ones, or only a faint lopsided glow. For observers, the playbook is straightforward and rich. Use ultraviolet to flag the freshest compressions, H-alpha to clock the offsets between shocks and ignition, mid-infrared to weigh dust heating, far infrared and sub-millimeter to inventory the cold stockpile, CO and dense gas lines to measure the true fuel, 21 centimeters to read the tidal handwriting, integral field spectroscopy to map the streaming, polarized radio to trace the field architecture. Stack those layers and the meat hook, the harpoon, the Volan's hook, pick your alias, stops being a curious shape and becomes a legible machine, rotation for rhythm, a bar for meter, a tidal nudge for accent, magnetism and feedback for orchestration, and a dark scaffold to keep the stage firm while new stars keep taking the spotlight. A wanderer without a sunrise slips through the crowded heart of a city of suns and finds the one thing that everywhere in the cosmos respects, a deeper well. Capture never happens in a polite two-body handshake, something must steal energy. In a nuclear star cluster packed with fast-moving elders and gas filaments, the vagrant world is jostled by near misses, draped in a drag of thin plasma, or stripped from a companion during a chaotic three-body scuffle. The result is a crazy, needle-thin ellipse around the dark engine at the center of the stellar metropolis, an orbit so stretched that most of its time is spent far out in the quiet outskirts, with a whip-fast dive that schemes perilously close to the invisible rim. On such a path the numbers stop feeling like astronomy and start feeling like choreography. Imagine a semi-major axis of 100 astronomical units around a central mass of 4 million suns. The period is months, not millennia, because gravity scales with the central heft. Let the eccentricity swell to 0.99 and the pericenter tucks near 1 astronomical unit, just outside where tides would start tearing an Earth-class body into gravel. Each loop the pericenter swings forward by tens of degrees thanks to general relativity, drawing a rosette in space, a rose sketched by time dilation. If the central spinner carries angular momentum, frame dragging twists the orbital plane as well, a subtle nod from spacetime that the core is not just heavy but whirling. Life on the surface, if there is a surface, becomes a physics seminar. Far from the abyss, the drifter is a deep space world, starless skies, a temperature set by internal heat and any blanket it carries. Thick hydrogen atmospheres do a surprising job of trapping geothermal warmth, and tidal kneading at each close pass adds pulses of energy that propagate like planetary heartbeats. The strength of that kneading depends on the world's elasticity and dissipation, the same ingredients that light up Jupiter's moon Io, scaled to ridiculous by the mass contrast. Rocks flex, faults creep, mantles stir, and on an icy globe, high-pressure oceans may swell beneath shell ice, then freeze a little between pericenter beats, riding a sawtooth of climate into the crust. The plunge is a different universe. The sky brightens not with a sun but with a glowing, asymmetric halo, the innermost gas of the central maelstrom. X-rays and hard ultraviolet surge during flickers of accretion, charged particles roar along magnetic field lines, the black circle at the center wears a thin ring of lensed light, a distorted promise that everything luminous behind it has been bent. Radiation eats chemistry for breakfast. Atmospheres puff, upper layers haze, molecules fracture and recombine into photochemical soups that rain hydrocarbons. If the world carries a magnetic field, its motion through magnetized plasma turns it into a giant unipolar inductor, driving currents that close through the surrounding sheath and ignite auroral ovals with energies that make Jovian displays look like candlelight. Pericenter is a storm season and an electrical season and a geology season, all at once. Whether the globe survives depends on the knife edge between gravity and material strength. The tidal radius for an Earth mass body near a multi-million solar mass monster sits of order half an astronomical unit. Dip inside that and the planet unthreads into a stream. Go too far and the debris becomes a luminous ribbon, wrapped into a tight ring by differential gravity, shock-heated where the stream intersects itself, and then bled into the inner flow as dust and gas, an appetizer for the central furnace. Skirt just outside and the world lives to loop again, losing a little orbital energy each time to tides within itself and to interactions with the ambient medium. Over many circuits, the needle ellipse shortens and fattens toward a tighter path. For small bodies that process is glacial, but the direction is one way unless another kick intervenes. Detection is a game of patience and cleverness. There is no host star to dim with a transit, no reflected sunlight to flash at opposition. Instead, astronomers would look for periodic infrared brightening as the surface or atmosphere is heated at closest approach, for submillimeter or radio bursts from induction-powered aurora, for faint, transient dust arcs if volatile ices sublimate and condense into rings that glint at certain viewing angles. The timing of those flares, together with their relativistic clock drift as the pericenter precesses, would betray the mass and spin of the central attractor. In a well-watched core, the bustling downtown of this island universe, precision astrometry could even catch the gravitational tug of a planet-mass body on nearby test particles, the way the famous S-stars chart the central gravity but on tinier scales. Chemistry on a captured nomad is written by extremes. With no daily sunrise, the default climate is stratified and slow, but pericenter injects oxidants, nitriles, and radicals that never see equilibrium. On a rocky world, magma ponds erupted by tides may glass over between passages, preserving layers like tree rings that encode the timing of each dive. On an icy colossus, methane clouds could seed hydrocarbon snow that is erased on the next furnace swing, a periodic resurfacing cycle that paints latitudes by orbital phase. If a thick hydrogen envelope exists, pressure broadening and collision-induced absorption can warm the deep troposphere into habitable temperatures even in the cosmic night. Add tidal power and you have a laboratory for life that ignores suns and worships gravity. Habitability here is not a soft meadow under blue sky, it is a dark ocean under ice, keeping its own calendar by the beat of spacetime. Dynamics in the central precinct of the star archipelago never rest. Resonant relaxation rattles orbital orientations as passing stars exchange tiny torques. Cosilitive cycles driven by the cluster can pump eccentricity higher and inclination stranger. A brush with a compact object can tilt the ellipse into a new plane. Gas streams drifting like luminous smoke can sap or donate angular momentum depending on the geometry, sometimes herding small bodies into families of similar paths that share a preferred pericenter direction. The vagrant story is therefore not just one world and one well, it is a swarm problem, a statistical ballet of millions of pebbles, rocks, comets, and planets responding to a central verdict. Seen from far above the disk of this stellar commonwealth, a captured wanderer is almost nothing, one more dust mote obeying the deepest gradient in town. Seen up close, it is a world with seasons defined by relativity, weather written by particle physics, geology set to the rhythm of a rosette, and chemistry that remembers every encounter with the photon furnace at the core. If astronomy's usual questions begin with, "What star does it orbit?" these nomads flip the script. They orbit a geometry more than a lamp, a piece of spacetime that sculpts orbits into flowers and time into spirals. The city around them, this spiral dominion, this star-crowded burrow, this luminous archipelago, provides the crowd noise and the occasional shove, but the dance belongs to gravity and whatever stubborn sphere refused to be unmade. Say the word, and the story dives deeper, into how the precession angle maps the mass quadrupole of the central engine, how ring systems survive the torque at pericenter, how a cryovolcanic plume would look silhouetted against a lensed background, how a world can be nightbound and still warm, how capture writes its signature where even the brightest suns are only scenery. Capture has a dozen doorways and each opens with a different creak. A common route begins with a planet tethered to a star that wanders too close to the dark turbine. Tides tear the system apart, flinging the lamp outward while the smaller companion is left behind in a thin, feverish ellipse. Another path starts even farther out, where this island of stars teems with binaries that swap partners in gravitational bar fights. A three-body ricochet can rob the drifter of enough energy to fall into the core's jurisdiction. Add in the gentle drag of thin, magnetized gas that threads the downtown of the starry republic, and a small body's fate shifts from visitor to resident. The end product is the same, a path with aphelion in the quiet suburbs and a pericenter drawn so close that the world tastes curvature. The physics of that taste is ruthless and precise. Tidal stress rises like a cliff as closest approach shrinks, scaling roughly as the inverse cube of distance, so a small change in pericenter means a large change in pain. Well outside the event horizon of a 4 million solar mass engine, a rocky globe still meets a survivable corridor. Just inside roughly half an astronomical unit the Roche calculus stops being polite, and mountains become molecules. If composition leans icy, the safe lane is wider. If iron heavy, the world holds together longer but bleeds heat with every flex. The energy pumped into the interior during a single dive can exceed Earth's global geothermal budget many times over, and that power does not distribute evenly. Weak layers decouple, partial melts pool at depth, fault zones unlock for a few frantic days, and then the long freeze of aphelion begins anew. Relativity rights flourishes on top of Newton's grammar. Each lap, the argument of pericenter marches forward, so the track is not a closed ellipse but a rosette whose petals open by tens of degrees per orbit. If the central spinner's axis is tilted, frame dragging also nods the orbital plane, a slow corkscrew that depends on the black hole's spin and quadrupole, exactly the combination needed to test the no-hair predictions of gravitation theory. Even a planet is a clock, comparing the timing of heat pulses, induced aurora, or dust outgassing from successive pericenters against a relativistic model constrains the central mass and spin the same way the S-stars do, only with a colder, smaller, stranger probe. What bathes the surface at closest approach depends on the central furnace's mood. In a quiet nucleus, the photon bath is thin and hard, rich in X-rays and ultraviolet that carve chemistry rather than warm oceans. During flares, luminosity can spike and the energy flux at 1 astronomical unit rivals or surpasses a sunlit day. That turns atmospheres into laboratories, hydrogen envelopes puff and cool into hazes, nitrogen-oxygen mixes spawn nitrates and peroxides, methane skies polymerize into smog that snows when the world coasts back into darkness. A magnetic shell amplifies the drama. Motion through the core's magnetized plasma turns the globe into a dynamo, currents close along field lines, joule heating adds to the tidal budget, and polar ovals become brutal, flickering crowns that inject chemistry into otherwise sterile air. If the traveler carries a ring system, the pericenter ram pressure warps and may even twist it out of the equatorial plane. Resonances can drive ripples that march around like barcodes a spacecraft could read from orbit, if any spacecraft could survive the trip. How would the luminous archipelago betray one of these hidden citizens? Start where the signal is most honest: heat. Near-infrared light curves that swell and fade on the orbital timescale would be smoking guns, especially if the peaks creep earlier each year by the amount predicted from pericenter precession. Sub-millimeter flashes from induction-driven aurora would ride atop that cycle like percussion accents, and in fortuitous geometries a thin dust wake, volatile grains boiled off at pericenter and sheared into a filament, might backlight against the crowded star field. Precision astrometry in the central parsec already traces the ballet of bright test particles. A planet mass body would be subtler, but in aggregate a population would add a small, correlated noise to orbits of nearby tracers that a patient interferometer could isolate. On the gravitational wave dial, a rock looping at a few tenths of an astronomical unit around a monster is too quiet for current ears. A super-Earth pressed into a tighter, faster rosette around a more massive dynamo could creep into the lowest bands of a future spaceborne antenna, whispering an extreme mass ratio murmur at millihertz. Origin stories matter because they leave scars. A world stripped from a star within this spiral dominion might keep a residual moon, and that companion can act as a heat valve, pumping eccentricity and modulating tides the way Io and Europa share energy. A body formed in the cold outskirts of the stellar continent, then scattered inward across kiloparsecs, would arrive rich in volatiles and poor in refractory crusts, favoring ocean underice outcomes and atmospheric hazes. A fragment of a shattered super-Earth might come preheated and metallic, its magnetic shield strong and its surface bare. Some vagrants will finish as streamers after one unlucky dive, others will circularize into close-in embers that feed dust to the central flow, and a stubborn few will surf the knife-edge corridor for millions of years, carving a private calendar into rock and ice. Between passages the night is honest and slow. Without a sun, climate is a negotiation among internal heat, blanket gases, and radiolysis by cosmic rays. Hydrogen-rich mantles can push deep tropospheres to temperate pressures and temperatures even in darkness, add tidal needing every few months, and a subsurface ocean becomes not just likely but vigorous. Life, if it cares only for gradients and solvents, could regard the whole nebular conurbation as a sky it never needs. Metabolism chews on oxidants laid down in storm seasons and waits out the cold. Biosignatures would be pericenter phasic, bursts of trace gases that rise, react, and fall on a schedule written by gravity, not daylight. The surrounding star-packed burrow never stops meddling. Resonant relaxation nudges orientations. Causative pumping from the wider cluster can trade inclination for eccentricity, occasionally pushing a survivor into the red line where one more degree of freedom means disassembly. Passing compact remnants, neutron stars or small black holes, offer impulsive kicks that can flip the ellipse or eject the traveler altogether into the deeper halo of the stellar commonwealth. Thin streams of gas drifting like pale smoke near the core can sap energy at some true anomalies and donate it at others, herding small bodies into families with shared pericenter directions, ghost belts that a sensitive telescope might map as repeating arcs of dust. Endgames are varied and theatrical. The unlucky shred into a luminous noodle, the modest settle into warm embers that paint the inner flow with fine solids, the rare bold few spiral inward over eons as tides and drag eat angular momentum, flirting with orbits so tight that relativistic beaming would turn the world's nightside into a time-varying lighthouse. Somewhere in the ledger of this deep sky province there must be a limit case, a super-Earth that schemes just outside the last stable path, lit not by a nearby lamp but by spacetime's violence, wearing auroras brighter than continents and an ocean that boils sideways only 1 week in every 100. That, too, is a planet, night-bound, time-scarred, tide-fed, owed to the same rule the whole stellar federation obeys: fall toward the deepest place you can find, and call whatever survives a home. Over long stretches the captured world becomes an archivist for the whole Star City's center. Each near miss with the abyss right separate, datable layers, a veneer of nitrates frozen after one bright storm season, a cracked dike where tidal heating forced magma into brittle rock on another loop, a lacy deposit of tholins laid down when ultraviolet flares ran especially hot. Ice shells remember in stratigraphy, rocky crusts remember in stress shadows that only relax during the far-out winter. Even the core keeps time, because tides pump energy at discrete harmonics of the orbit and those harmonics drift as relativity slowly rotates the ellipse. A geophysicist dropping a seismometer here would be reading the ephemeris of spacetime, not the calendar of a sun. Close Passage has its own weather. The planet plows through dilute but angry plasma threaded by magnetic fields. The flow wraps into a comet-like magnetotail and a bow shock grows ahead of the nose where neutral exosphere gas meets relativistic wind. Sputtering and charge exchange carve atoms from the high atmosphere and turn them into a faint, elongated cloud that the next orbit shears into a filament. If the globe carries rings, ram pressure kinks their edges and differential precession winds them into spirals. Self-gravity and collisional damping then rebuild order between passages, like a record that warps in heat and then flattens under its own weight. Moons complicate everything in beautiful ways. A small companion can pump the big body's eccentricity, modulate tidal heating on beat frequencies, and see transient arcs of dust that flare in forward scattered light as the pair schemes the inner glow. Energy bookkeeping sets the long arc of fate. Tides within the world steal orbital energy and stash it as heat. Tides raised on the central giant don't matter, but tides raised by the planet on itself do. The conversion efficiency depends on the love number and quality factor, how deformable and how lossy the body is. Rubbery ice shells and partially molten mantles turn orbit into warmth better than rigid iron. In dusty inner gas, hydrodynamic drag dozes along, shaving a little velocity each pericenter. Over many circuits, the path shortens and rounds, the pericenter lifts, and the heating softens. Some refugees eventually settle into warm, near-circular tracks in the inner glow where they become stealth heaters of the local medium, shedding fine solids that drift inward and thicken the luminous fog. Others never calm down. A perturbation from a passing remnant or a secular push from the surrounding cluster ratchets the eccentricity upward until the safe corridor narrows to nothing and the world shreds into a ribbon. The ribbon stage is its own astronomy. Tidal debris lifts into a thin stream whose inner parts race ahead and outer parts lag, where the loop closes on itself, self-intersections shock and light the gas, and a broken ring forms that slowly feeds the central engine. Dust grains sputtered from the stream pick up charge and feel Lorentz forces, painting the inner precinct with faint, polar-aligned brushes. If any of that debris crosses our line of sight to a bright background tracer, the light curve would show multiple, sharp-edged dimmings spaced by the stream's thickness and the ring's precession. The geometry would be a decoder ring for the mass and spin of the core and a post-mortem for the world that didn't make the cut. Between catastrophes, biology has room to try things. A hydrogen-rich cloak can push the deep atmosphere to temper pressures even in eternal night. Add ammonia, methane, and water and you have a chemistry set that resets at each fiery swing but never fully erases. In an ocean sealed under ice, pressure-induced clathrates and antifreeze salts can keep brine liquid while tides stir it like a slow piston. Oxidants laid down during auroral seasons diffuse into the dark and feed redox metabolisms that care about gradients more than skylight. If anything living evolves timing, if enzymes anticipate the hot week by upregulating repair pathways and membrane chemistries before the plunge, it would be a life that reads gravity as weather and relativity as calendar. Signals for telescopes must be chosen where the contrast is kind. Thermal emission is honest. Pericenter spikes in the mid-infrared, decays over days to weeks with a tail set by heat capacity and circulation, and returns on schedule with a phase that creeps as the ellipse rotates. Polarization is a second handle. Forward scattered dust from a transient ring produces a polarized flash that peaks slightly before the thermal crest, and the offset grows if the ring is tilted by frame dragging. Low-frequency radio from unipolar induction sets a clock that jumps when the magnetosphere reconnects. Line emission from sputtered neutrals, oxygen, carbon, sodium, traces the exosphere's size and tells whether the atmosphere is being eroded or merely roughed up. A handful of orbits, modeled together, would weigh the central anchor, test for spin-induced nodding, and even hint at the traveler's interior through how quickly it turns orbit into heat. Capture demographics are written by the wider star continent. Barred systems funnel gas toward their hubs, thickening the medium and boosting drag capture for pebble-to-comet scales, while rich nuclear clusters elevate the rate of three-body exchanges that can swap planets off their host lamps. Ellipticals with giant central engines have bigger safe lanes for rocky bodies. The event horizon is larger but the tidal radius scales more slowly, so some retain captured super-Earths that skim within a few tenths of an astronomical unit of the rim and light up like lanterns at each dive. Dwarfs with small cores are harsher. The tidal radius shrinks until rock must venture so near that survival becomes unlikely and ribbons are the rule. Different neighborhoods breed different fossils. Navigation through this inner ward is a textbook in subtle torques. Resonant relaxation trades angular momentum among orbits with similar energies, random walking the orientation in a way that can be faster than two-body scattering. Cosyllative cycles from the broader cluster tilt and stretch paths, sometimes stalling at high inclination where pericenter distances hover near the danger line for long intervals. Spacetime itself adds Lady's handwriting on top, apsidal advance from curvature, nodal drift from spin, tiny extra twists from the quadrupole moment if the central spinner is not a perfect sphere of gravity. Track those twists carefully enough and you are testing that no-hair statement with a planet as your pen. Material properties decide microscale outcomes that telescopes can, in principle, see. A silicate globe with a thin atmosphere radiates heat in sharp pulses and shows strong orbital harmonics. An ice-rich body wears a deeper thermal memory and peaks later and longer. A mini-Neptune with a puffed hydrogen shell shows broad, muted crests with photochemical afterglows that last into the cold months. Magnetic moments matter. A strong dynamo breeds radio bursts and fierce auroras. A dead core leaves only the sputtered exosphere and dust. Rings survive if self-gravity and collisional damping can beat differential precession. If not, they dissolve into transient spirals that recur each hot season. Moons persist if their hill spheres stay intact at pericenter. If the line tightens too far, satellites are peeled away into their own brief, beautiful lives as inner debris. The violence of closest approach also forges minerals that elsewhere need deep crustal ovens or large impacts. Shock veins freeze into masculinite-like glasses, high-pressure ices build and unbuild, iron sulfides rearrange, nitrides and cyanides condense in the upper air and snow out as brittle films that crackle electrically under auroral rain. Meteoroid environments spike because the inner precinct is dusty and many bodies share similar paths. Impacts prefer the weaks near pericenter, so craters cluster in longitude and carry vitrified splashes that betray the direction of the plunge. One can imagine reading, centuries later, a run of closely spaced microcraters on a rover's hull and inferring the exact argument of pericenter that year. Some refugees find a loophole. Mean motion resonances with other small bodies near apicenter can freeze the pericenter distance at a safe value even while the rest of the ellipse precesses. Those resonant shepherds form ghost families, swarms that share a preferred closest approach and, viewed edge-on, draw repeated arcs in scattered light inside the central glow. Others are guided by gas. Weak, steady drag can herd populations into narrow corridors of phase space, the way snow fences cause dunes. In a richly fed nucleus, these soft forces can outweigh random kicks, creating long-lived belts of invisible worlds that announce themselves only by their synchronized heating. Push the parameters to their limit and stranger scenes appear.